Okay, thanks Jeff for the introduction. Hello everyone, I'm Chiu Wu. I'm from University of Tennessee. So for this morning, we're going to go through cloud computing, Google Engine. And before we get started, I would like to know how many of you have used Google Engine before? One? Okay, great. So hopefully after today, you'll be convinced to use it and you see the benefit of using cloud computing. So first, I would like to show you how to get access to the content. So for today, we're going to do hands-on coding. So how many of you have used Python programming before? Okay, maybe more than half. Great. If you don't worry. It's super easy. All you need to know is how to click the buttons. That's it. And you can make changes. Even if you have no coding background, you will be able to follow. But we do need to sign up the account. After that, you'll be just like clicking the button, following through, and then if you want to make changes, you can do that. Otherwise, I'm going to show you a lot of cool stuff, how you can use cloud computing to do larger scale geospatial analysis. You can get any data from the Earth Engine data catalog. So it has over 100 petabyte, 100 petabyte, 1,000 terabyte, 100,000 terabyte. So tons of data. And the take-home message from the workshop today is I'm going to show you how to watch movie on Netflix. But in geospatial domain, how to stream data from the cloud, how to do computing, how to do analytics, how to create some cool animation, for example. And I'm also recording the video. Don't worry if you cannot follow. If you want to rewatch it after that, you better do that. I will post this on YouTube so you can follow through. Or you can share with anyone who might be interested in learning cloud computing. So first, go to the website, geemap.org. So just open your browser, and then you need to log into your Google account. So we're going to use Google Collab. Basically, it's a cloud computing environment for you to write Python code and execute Python code. So before we do that, how many of you have used Google Docs? Or Microsoft Word document, like online, like you probably have used some of those before. Google Collab is very much similar, but it's for coding and it's free, so we can use it to do some programming. So once you are on the website geemap.org, on the left side you should be able to find workshops. On the second last one, so geemap.org. So find a workshop and then scroll down to the bottom here. Find the last one, HGSC 2024. So this is the one we're going to use. And you can see the past workshop here. Every year I give maybe a couple of those workshops. They are kind of similar, but not always the same. So this will be the latest one. So it's kind of 3 hours. But I have taught this ranging from 1 hour to a whole week, 24 hours. So we have a lot of content. Depending on what you need, we will be flexible. We don't need to cover all the contents, but the notebook has everything that you need to get started with Google Engine and cloud computing. Okay, can you find this one? HGSC 2024? All right, so once you're here, you can see this is basically what we're going to go through today. It's a very long document. On the right here, you can see the table of contents, so you're welcome to skip through. We're going to go through step by step and then show you how to get started and how to get some data. Basically, how to watch movies, but how to stream geospatial data, and that's it. And all we need is just a couple lines of code. Things so much easier now than a couple years ago. So this Geemap is basically a Python package that can help you do cloud computing with Google Engine interactively, very easy to use. So I created a package a couple years ago. At the time, Google Engine, the Python API was not very easy to use. So I kind of created a package to make it easy for you to stream data. Think about Netflix as a not a movie. But in the past, if you want to watch a movie, it's not so easy. You need to go through a lot of steps. But now all you need is to open a browser. You can search, and then you can watch movie on Netflix or YouTube or whatever streaming services you're going to use. So very much similar in here. And one thing I would like to highlight here is if you're still right now downloading data from USGS, from NASA, and trying to do things locally, you're going to have a hard time in a couple years, okay? So right now it's probably still okay. And if you're doing remote sensing, maybe you have used some data from Landsat, from Sentinel. You can download data, maybe a couple of gigabytes to a computer, unzip, and then just trying to do computing. But in a couple of years, the satellite is going to be improved, and the resolution is going to get much higher. So for example, from 30 meter to 10 meter, and the spectral band is also going to double. So the file size, for example, for Landsat, one image sync is going to increase 20 times. So right now it's 1 gigabyte. It's pretty fine. You can download data, you can process. In 2030, NASA is going to launch Landsat next. So one gigabyte will become 20 gigabyte. And you will not be ready if you don't know cloud computing. So certainly now is the time to catch up. Otherwise, when the satellite is launched, NASA is like the Johnson Space Center is here. You'll be watching people doing cloud computing, and you will just like sit there downloading the data, take you hours. People go online and then just stream the data, like just like you can watch high definition movies on YouTube or Netflix. You just open it, you just watch it. You don't need to worry about downloading the data. So that's the whole point of using cloud computing. And so this is what we're going to achieve today. And if you have never used Google Sensing, hopefully after today, you'll be convinced to use it. And it's free for research, education, and also non-profit. If you use it for commercial, you do need a license. But for us today here, everyone is welcome to sign up. It's just like sign up a Gmail account, and that's it. And then you can start doing all kind of computing. So let's kind of a brief intro. So next, let's get your hands on Google Sensing. So there's a link here, open in Google Collab. So just right click and then open a new tab. For example, to open this one on Google Collab. And it's going to take you to the Google Collab environment. So Google Collab basically is a cloud computing environment that you can run Python code. It's provided by Google, it's free. And so nice thing about this, you don't need to install any single computer. So all you need is just a browser, that's it. But after you open, upper right corner here, if you're not logged in, make sure you log into your account. So you need a Google account to be able to do cloud computing. So just take a couple seconds to log into your Google account. If you don't have one yet, please create one right now. So you do need an account, otherwise you'll be watching, okay? You won't be able to really get your hands on the data. All right, so are you all signed up? Log in? If you need time, please speak up. Yes? So on the left side, workshops here. And then scroll down all the way to the bottom. And then this one. All right, and then right click here. Open a new tab. Oh, it's the first one. All right, and yeah, and then go to this one here and sign in to your Google account. So let me zoom in a little bit. If you're not ready, raise your hand. We can slow down. Okay, a couple of people. So sign into the account, your computer, and then log into your Google account. You need to create a Google account yourself. I cannot help you create an account. So just sign up for a Google account. Then we'll show you how to sign up for Google Sensing. So for those of you who are ready, here I have 3 links in here. So the second one, Earth Engine. So if you want to look at the Earth Engine website, you can click opening a new tab, and then you should be able to go to the website. So this is the website for Google Sensing. And so Google Sensing is different from Google Earth, okay? Google Earth is just for visualizing satellite data, and you cannot do any analysis. You cannot download any data. So those are basically the commercial, most of the high resolution imagery for commercial, and not for commercial, but it's free for you guys, but you cannot download the raw data. Google Earth Engine is the compute engine behind Google Earth. So a lot of images that appear on Google Earth might have been processed by Google Sensing. So one analogy would be like, Google Earth is just like the image viewer on a Windows operating system. Google Earth Engine is just like Photoshop. So you have a lot of editing, a lot of functionalities to computing to do analysis. But Google Earth, you cannot do anything. It's just for viewing only. There's no analytical functionality. So Google Sensing was launched in 2010. It's almost 15 years, but they only released to the public, I think, until 2014. So it's roughly 10 years by now. and it has been very popular in the geospatial community. It's also probably the most popular cloud computing platform for doing geospatial. And we don't have time to go through all the details in here, but I'm going to show you how to use Python. But you can check a look at the website. And one thing I want to point out here is you look at the data set. So if you click the data set tab here, you have pretty much most of the common data set being used in remote sensing. You will find them in here. All the satellite data, land use, land cover, weather, and climate. There are tons of data in here. And all the data are being updated constantly. So at least daily. So you have access to the most up-to-date data. You don't have to go to NASA or USGS to download the data. Everything is just out there. Just like you are watching like all the new TV shows, right? HBO, whatever. Once it's released, it will get ingested into the data catalog, and then you can just stream the data right away with just a couple lines of code. So this is a huge data catalog. Again, 100 petabytes, and it keeps growing. So it's a base freely available data catalog. And so next, let's get started with the sign up process. So you do need to sign up for a Google Earth Engine access. So again, right click, open this one, and then come to the Earth Engine webpage in here. And if you go to, maybe, let me go to the first one here. So upper right corner, there's a button here, get started. So if you don't have an account, you will need to sign up. So go to the Earth Engine website, and then click this button here, get started. And you come to this page. Are you ready? Then we can go through the registration process. Sign up for it, log into the account. Are you able to see this page? Not there yet. So go to the Google Earth Engine website, and then upper right corner here, click this button, get started. If you're running into issues, let me know. You need an account, otherwise you won't be able to do anything. You can watch, but you won't be able to. So if you already log into your account, that's great. Go to the Earth Engine website. No, go to the notebook, the GIS map, and click the first one, and workshops. Scroll down all the way to the end. No, this one, and then HGSC 2024. Okay, and then open in Google Collab. Click. All right, and then the second one, right click. Oh, it's fine. Okay, and then get started. Okay. Are you all ready? Oh, you already, that's great. So, but let me see here if you already signed up for. Let me double check here. Form coordinator. So, do you have a project info? Yeah, you're good to go. So you don't need to do anything. For those of you who are new, then let me quickly go through the process how to register for a cloud project. So basically, in the past, it's not required, but now all Google Engine Cloud require cloud project. It's free. You don't need to pay anything. But cloud project basically is keep track of your uses. And Google has the huge cloud computing services. All the cloud computing will be using a cloud project. Use the cloud, create the cloud project to use Google Engine. It's free, but be careful about using other services. Not everything is free, so you don't want to end up with a big bill if you use other services. But just for today, it should be free. And so register on a project, and you want to select this one and pay usage. And for the project type, for today, we can just use the academia. Like I said, it's free for research, education, and non-profit. If you use for commercial stuff, you need to pay. But for this training here, you can just select the academic and research. Okay? And then next. So if you don't have a cloud project, if you're just new, you have created a new account, you might need to create a cloud project. So for me, I'll just create a new cloud project. And by the way, if you log into your Google account, I'm not sure if any of you are students. Don't use your university EDU account because you may not be able to create a cloud project. So if later it shows that you cannot create, you need the permission, that means your university IT has disabled the functionality that allows students to create a cloud project itself. Because like I said, the cloud project is free, but you can use a lot of stuff. Just like you have your Amazon account, and then you watch a lot of premium movies, at the end, the university need to pay, okay? So that's why they don't allow you to create a cloud project yourself. But if you log into your personal account, you should be fine. So for here, by default, it should pull up this ID, and then you can just continue the registration. And for me, because I have already created a project before, so it doesn't allow me, I can change it maybe to EE. The name needs to be unique, okay? So it can be EE anything, or you can just give a random name. So for example, I will see EESGAC, something like that. If I'm using this one, you cannot use it, okay? It's a unique identifier across the globe. So anyone using cloud services, there's a unique project ID. So choose whatever name you like, and then just continue registration. And you should take a couple seconds, then you should be able to create, you will pull out another window, and then you just confirm, and then you'll be good to go. So right now it's basically checking if the name is unique. If yes, you see, now I'm passing through this step, and then just confirm. All right, and we say project EEHGAC is registered. So that means right now I'm good to go. And then it should be presented with this one, the JavaScript code editor. So this is where you do JavaScript coding. But for today, we're going to use Python. So we don't use this one, but we need a cloud project to authenticate Google Engine. Yes? Oh, that one you don't need to. It's free. So it's fine. Just confirm. It's free. Yes. Let me see. So if they show an error message at the bottom, it says you need to read and accept the term of service. Just click the button at the bottom, and then just somewhere, check the box, agree, and then go back and then try again, click again. Yeah, if it is the first time, at the bottom it might show you you need to accept the term of service. Just click the link, and then open it up, check the box, agree, and then you should be able to go back to create a project. So how many of you have arrived at this interface? Who have not? 1, 2, 3. Okay, so please do it. I can help you, but you need to log into your account, and then it should take just a minute or two. Once you have that, it should be, so if you see the interface, then you are ready. If not, you need to do it right now. Yeah, it's confirming, and then it should redirect you to the interface. You ready? Okay, great. Oh, you are a lot more advanced. You already, okay. So looks like almost everyone's ready. Okay. So here, remember the project name that you created. So upper right corner here, you can click this one, and you should be able to see the project information. So basically what we need is whatever project ID that you chose, there's the ID that we need to do the coding. So if you click here, you should be able to find this one. So you can just select, for example, copy it, and we use it later, okay? If you remember the name, then you don't have to copy. You can just type it later. So this will be the JavaScript code editor. This is where you do kind of programming, but we're not going to use this one. We're going to use Python. But if you want to try things out, you can certainly do that. So on the left side, here, basically, there are all kind of scripts. You can actually taste things if you want to. This is where you write Python JavaScript code. And here is where it's going to show you the result. On the right here, basically, you can do some inspection, do stuff. So for example, you can click on the left side. From here, you can select whatever you want to test. So for example, I can click this one, normalize difference or something, and it's going to populate the JavaScript code in the middle. Then all we need is just click this run button. See? So you can select whatever you like. For example, I chose this normalized difference. And once you click, it will populate the one in the middle. Click this button. There should be a button here at the top, run. So click the run button, and you should be able to see the result at the bottom. See that? And this is a global scale, for example, imagery. How long does it take you for you to load the imagery? Less than 1 second, okay? And here you can see the layer. You can see the original imagery. You can see the NDVI. And this is what cloud computing is about, streaming the data. And you don't need to wait. You're just watching the data coming into the browser. And you can do all kind of computation. We'll show you later, but using Python, not using JavaScript. And you can also, upper right corner here, inspector. So you can click the inspector tab, and then you can hover your mouse on the map. You can click on the map, it should be able to inspect. It can show you all the pixel values on the right. So click this inspector tab here, upper right, and hover your mouse on the map and see what is showing up. So it might take a couple seconds because the data is in the cloud. So you actually getting your coordinates, send to the server, do the computation, get the result, and send it back. But this is very much similar to like doing desktop computing, like you're loading the imagery on QGIS, ArcGIS, and then use the inspector to do that. But this is kind of unlimited because you can load global scale data easily, just a couple lines of code. Although here right now looks complicated, it's not so complicated. So I'm going to show you how to do that. Yes? Yes, you can do whatever you like. So you can do anything. So for example, certainly there's maybe some, let me see if there's any lane set data in here or not. Or I can show you, you can go to the Earth Engine webpage, go to the data set, right? And then from here, you can scroll down to find lane set here. So lane set has the entire archive. For example, I can take a look at lane set 9, okay? And from here, choose the data product you want. I can choose the service reflectance. So for every data product, you can also have the tier 1. Oops, let me see here. Once you click at the bottom here, usually they will show you the sample script. So all you need to do is just copy this one. You can customize it, but you do need to know some syntax. But I'm going to show you how to actually to filter the data. For example, we can find all the images covering Houston from the entire length mission. We can create the time series just with couple lines of code. So what you want is to find the data set you want, find a sample code, and then copy this one. Come back to the Earth Engine code editor. Control A, Control V. Run. See? Now it's lane set, right? And there's not really, you don't need to download any data. So this one pretty much, I think it's also at the global scale. Although you see all of the cloud because we're just filtering the data. But you can create cloud-free mosaic just with a couple lines of code. So you can find any data set, or they always have a sample code for you to visualize the data. It can be lane set, it can be DM, it can be all kind of things. So for example, you can load the entire 3-step, like high resolution, 1 meter resolution DM. So for example, let me go back to, where's the data set? Somewhere here. So I can go to maybe the reorder data set. So you're going to see the entire data catalog. Right now, it contains almost 1,000 data set. Each data set, it can be the entire mission. So 1,000 might seem small, but one data set can be hundreds of terabytes because you have the entire data catalog. So here, for example, I can source DM or maybe 3-step. For example, right? You can see the 10 meter and 1 meter, for example. This one is many, many terabytes. So you can look at this 1 meter resolution USGS 3-step program. And again, I'm just going to copy this script. Come to here, Control A, Control V, run. Now you have access to the entire 1 meter resolution DM for the entire US, loading on the browser. Imagine you have to download this one to your computer. It's going to take you weeks. And even if you can download it, you won't be able to do the computation because it's so huge. But look at here, although it's going to pop up slide by slide because it's retrieving the data, doing the resampling, and then just showing on the browser based on the zoom level. So it's very, very useful, especially you need just to look at the data. I need to find some data, you know, see the data. This is the best freely available cloud computing platform that you can get right now to stream the data. Yes, some of those. So basically, this right now is just like similar to you're looking at Google, Google Map. is caching some of the tiles on computer. So the reason why it's popping up, because it go behind is like hundreds of servers, not hundreds, thousands of servers around the globe. So it's caching some of those on the computer based on the zoom level. So if you really want to see, like, for example, why it's popping up like square by square, because it's small tiles, and then it puts them all together, it looks like seamless. But behind the scene, if you go to, for example, you want to see how it works, go to the here, you can open the more tools, open the development tools in the browser, and it will show you actually how this one is being rendered. So if you zoom in, if you click this one, I think the sources, and then go to see the network. So when you zoom in, you should be able to see like it's popping up. It's actually requesting the tile. So if you open any of those, maybe this one. So it's like square by square. So it's small tiles by small tiles. So this is how the browser works. It's called HTTP range request. So you have, think about, you have an entire image in here, and each image like come from like hosted in different server. So it's requesting one type from one server, the other type from another server. So basically, if I want to do something, I want to ask each of you to do a small piece. You process Houston, you process Dallas, you process something. And then when the user asks like, okay, I want to see the entire US, you send the small tile to me, you send one small tile, and it looks like seamless, but it's not. It's like behind the scene, it's like this small. So when I'm zooming in, if the tile is already been cached on a computer, it will not download again. But if you zoom in like very high resolution, you see it's going to request the tile, and behind the scene, it looks like this. So this is how cloud computing works. We don't download the original data. We download the data that has been rendered, and it's exactly the same as like you're watching movie or YouTube. You don't download the entire movie all at once. When you fast forward, you will download that frame at a certain time, and depending on your computer screen and your resolution, you don't need the native resolution. So the data, for example, the DM is 1 meter. We don't download the 1 meter. Otherwise, you're downloading hundreds of terabytes all at once. You are downloading a subsample as a coarse resolution, depends on your zoom level. So if you zoom in very high resolution, very detailed, your areas become much smaller. So at the end, it's still a small size, small file size. If you zoom out, you don't need the native resolution 1 meter. It can be 10 kilometers. You can download a large area. So basically, you can think about it's a pyramid. And so it's only requesting the data based on your zoom level, based on your map view area. So exactly what this one is about, right? If I zoom in, you are getting a more detailed tile. It becomes, the color looks like this. It's not very obvious, but if you zoom out, it's going to download, for example, for the entire US in here. You see it's popping up. So the square becomes larger and larger. That means the resolution becomes coarser and coarser. And say it again. Oh, MTL means we don't have the data. So the 3-step digital elevation only cover most populated area. If it's desert or something, there's nobody care. You don't need. Yeah, you need to pay. It's very expensive to acquire the data. Yeah, they might have restriction, but in general, I think that it's trying to get the national coverage by 2027 or something. So in the next couple of years, even for the gap, they might all be filled. But we also have, if for coarse resolution, for example, that one is 1 meter, but for 10 meter, we have national coverage. So for example, I can go to, this one. For example, let me show the 3-step. Oops. No, you don't have to. So the browser will handle that. So after a while, if it's not being used, the system will clean it up. Yeah, so it's not going to take up too much space. So here, for example, the 10 meter resolution, this one is national. So if I copy this one and then go to the browser here, remove this, Control V, run. Right, so this one looks so much better. Right, this is 10 meter resolution. Again, it's several hundred gigabytes because it's 10 meter resolution. I used to download this one entirely to my computer and doing the processing, doing some mapping, depression, mapping some features. It took me a while to download from the US, yes. But now, like 1 second, you get the entire DM. You can calculate the slope. You can calculate whatever you want, and think about how easy it is. Just one line of code. I want to calculate the slope for the entire US. One line of code, you get the result. You can do the streaming. Okay, so hopefully You see the benefit of using cloud computing. You do need to know some coding, but it's not super difficult right now. Nowadays, especially with auto ChatGPT, you can learn on any computer language that you want. You don't even have to know it. You just ask like, how do I do this? Show me the sample code, and then you just make some small modification. Then you'll be able to get things done. All right, so this about the introduction. We already spent half an hour. So now, next, let's really get started. How to do the coding? How do we really start doing the programming? And so once you go back to the Google Collab, so here, right now, I think I'm using the dark mode, but some of the things might not show, the dark mode might not be fully supported, so I would recommend you switch to light mode just for this workshop. So go to the upper right here, this setting icon, and just change this one to maybe the light mode. In that way, your interface will look the same as mine. So change to light mode. It's more clear. And after that, we need to install the libraries. So for this workshop, we need Geemap and also a couple other packages. So what you can do here is go to this first line of code. And so for using Jupyter, for Google Colab, there are a couple keyboard shortcuts. So for this one, you can press Control/ for uncommon, or you can just manually remove the hashtag at the beginning. So hashtag means it's a command, it's not going to be executed, but we do need to install the packages. So just remove the hashtag at the beginning and click this button, or you can press Control Enter. So I will show you other shortcuts later, but for now, just click this button and run anyway. It's going to take you maybe a minute or two to install all the packages. So keep in mind, don't close this one, okay? So this is a temporary cloud computing environment. If you close the tab, you'll be gone. Everything will be gone. So okay, don't close it. And it's basically a virtual computer in the Google server, and it's free. Upper right corner here, if you see the RAM and also the hard drive, so it's 13 gigabyte of RAM and also 100 gigabyte, 107 gigabyte. It's a pretty decent one, okay? It might be better than your personal computer. It also has GPU. We don't use GPU today, but it's pretty very good for doing teaching and training, because you don't need to install anything on your computer. You don't need the permission. You don't need anything. Just a browser, and it's going to use your personal account. Okay, so after it's done, you should be able to see successfully install blah blah, and it's a very long text. On the left side here, if you want, you can click this button and then clear selected output, so it doesn't show up the output. Okay, and in that way, we have everything ready. It should be good to go now. And so next, click this one, import EE and import Geemap. So this is where you might want to use shortcut. Okay, so there are 3 keyboard shortcuts I want to show you right now. One is Control Enter, Shift Enter, Alt Enter. Control Enter means we're executing this code block, and it stays, your cursor stays within this code block. Or you can use Shift Enter, you execute, and then move your cursor to the next one. So for this workshop, I recommend using the Shift Enter, because when it goes step by goes to the next one. So look at this one, right? I press Shift Enter. You see it. Did it go to the next one? No. Oh, I press Control Enter. Sorry. And or you can have Alt Enter. Alt Enter means you execute, and it's going to create an empty code block beneath. If you want to try things out, you want to execute and then Alt Enter, you will create a new code block. But you can just Shift Enter, or if you don't want to use keyboard shortcut, just click this play button. You'll be fine. Okay. So importing the library. So if you have not used Python, basically Python is a programming language, and it has a lot of third-party libraries that we can utilize, so you don't have to build things from scratch. And the next step here, this is the one that's critical. So you do need to, right now, try run this one, see if you get any error messages. You probably will. It's going to show you that you need the project. So if you run this one, for me, it should be fine, because I have. You need to allow. So click allow, and then log into your the Gmail account. And you recently changed blah blah. Okay. You should not get this one. Let me see here. Okay, continue. And so at this pop-up here, make sure you click this one. Select all of them. Select all of them because we need to access to the Google sensing data. And just click continue. And you probably expect this one. You want to see this arrow message? This within expectation because we haven't set the project here. So where do you find this project? It's the one that we signed up earlier, right? So if you don't, you can go back to your Google Sensing account up right here. It's basically this one, or you can click the project information and just select here, select the project, Control C, and then come back to here, replace the none, remove none, and double quotes, and put your project ID within the double quotes, something like this. And if you run again, it should work now. Okay, project equal to double quotes, and then put your project ID inside, and then run it again, see if it works. If it works, then you can continue to run the next code blocks. Oops. Or has not been interesting. Is disabled. Interesting. Let me click this link, see what happened. It might be because I troubleshooting with that same error message. That's weird. I think I've did that before, so our project you can. If not, let's try this way. EE.authenticate. And then false equal to true. Let's try. Let me try again. And EE. Yeah, let me test it quickly because I was trying to create a new account so that you guys can follow the step by step. So this looks like it's working, and let me try this one again. Okay, so that means there's something wrong with the function. Okay, this one works. So do this way. Just type this one, EE authenticate. You don't need this one. Just type EE.initialize, initialize uppercase, and then the project equal to your project ID. Try this one. EE.initialize. If you type EE and then dot and then you pop up. So uppercase, and then inside the parentheses, project equal to your project ID. See if it works. So something wrong with this function. I probably need to fix it. It works. And if it works, and then you can click Geemap and then map. If you can see the map, that means you are ready to go. If you cannot see the map, then it's a problem. Yes? The same project. You use your own project ID. Huh? Yeah, that's what I'm saying. Something is wrong with the something is wrong with the Geemap function. So just for now, just use this one. I will fix it later. So just EE initialize, and then project equal to whatever your project ID. Then hopefully it should work now. And then you can run the next code block Geemap.map and then map, and see if you can see the map. So how many of you can see the map now? Not yet. Permission denied. let me see here. So try this. If it doesn't work, like E authenticate false equal to true, we authenticate and then E initialize. So if it doesn't work, let me know. Let me. Yeah. So create a new code block and EE authenticate. So here, let me just do this. EE So run EE authenticate and then EE initialize parentheses and then copy whatever you project equal to double quotes and then just type in your ID. Okay, run the call. Okay, yeah, good to go. And then just run the next code block, the map. And go next one. Click the map. The next one. Run it. Yes. Okay. Cool. And yes. Yeah, just type EE. Oh, it's pretty small. I need to make it bigger. Yes. Go and then run next one. Yeah. And scroll down on this one. Yes, you're good to go. Okay. Does it work? Yeah. Oh, awesome. How about you? Yeah. No. Cancel. So run this one and then create a new code block. Take this here. And EE authenticate. EE yeah, authenticate. Yes. Select that. Just select from the list. Or hit tab and then parentheses. And then run it. Control enter. Control enter. Oh yeah, it's running. Yeah, so same thing here. Let me run this. Just type EE authenticate. And then EE initialize. And copy the project. Okay, and then okay, yes. So same thing here. You'll be EE authenticate, and then let's change this one to EE uppercase. Yeah, good. Anyone else having issue? You need to project equal to double quotes. Double quotes, yeah. Yeah, EE something, yeah. Put your cursor inside.
That's what I should be seeing.
Yeah, yes, yeah. If you see the map, then you are good to go. Okay, and then run the next code block here. Image map, and then click the map. Next one. Next one. Yes. Okay. Anyone else? Are you all seeing the map? Sorry about the technical issues, but that's the first obstacle. Like many people kind of feel not easy to use, but after this one, it should be fine. So this one you will always need authenticate and then initialize. So authenticate basically you are logged into your Google Sensing account. Initialize, that means you initialize a Google Sensing section because I think they have a limit of 5 concurrent sections. Just like you are trying to watch a movie on Netflix, they don't allow you to share your account with all your family, right? You can only maximum with limited to a certain IP. So it's checking the usage of your account. So anytime if you reopen this one, you need to run this authenticate initialize again. After that, you should be good to go. So, and moving forward, all we need is just to run these code blocks. So next we can quickly go through how you create a map, how do we streaming the data. But for now, you are ready to go. We have authenticate, so you can start running through, for example, all the code block here. just explore to see how it looks. You can change by default, it's going to create a global map, right? So Geemap.map basically create an empty map, and then we can start loading some data to on Google Search Engine. So going forward, I'm going to use my local desktop because it's a lot more smooth. But you can continue to use this one. The interface will look very much similar. So I'm going to open my local one. So if you want to run it locally, you can do that as well. So you can download this one to your computer, download this notebook to your computer. But just use Google Collab if you are beginners. And if you want to install things on a local computer, you can also install it. But you do need to know some Python coding skills. So I'm going to just open this one on my local computer. Again, don't follow me on this step. I'm just using my local computer to run it. So this is called Jupyter Lab. It's kind of similar to the Google Collab. And so let me run this one here. Let me zoom in a little bit so you can see better. Is it better in the back? Good. Okay, so similarly, I'm going to just run this one. You don't need to follow me for this step because you already authenticate. Oops. Interesting. So probably something has changed for the for Google. In that way, maybe I can just use this one. Okay. I will switch to local version later. So here you can create a map. So you can set the center. For example, create a map. You can provide a center. So this is latitude and longitude. So what you can do here, you can create a map center around a certain location. For example, whatever you like. So if you want to, for example, create a map center around Houston, I can create a map and somewhere here, for example, you can zoom in. I can find where's Houston here, right? So you do need to know the latitude and longitude. So if you really want, you can come here. You can place a marker, for example, on the left side. Place a marker on the map, and you can find the coordinates, right? So right now this is the marker here. Again, you can use this icon here to place a marker on the map. And after that, you can get the coordinates. So upper left corner here, create a new code block. And so once you create the map object, you can reference the information. So for example, right now, you can also reference the map center. So here, right now, you can move the map around and just type m.center and run it. You should be able to get the center of the map, the latitude and longitude. You can also run m.zoom. You should be able to get the zoom label. So this is what the map looks like. So sometimes you want to create a map and then center a certain location, then you can do it like this way. And after that, just copy this latitude and longitude. And you can come back to the code block above. Then you can replace here the latitude and longitude. Just Control V and just put, for example, 13. If you run again, so the map right now is center here. So basically you can pick up the latitude, longitude, whatever you like, and the zoom level. You will create a map based on your input. Make sense? And so here, for example, Knoxville, you can also disable some of the controls. By default, the map we created, this one, on the button on the left, upper left corner here. And this one is the data control. So you can source data. I will show you how to do that. This one is zoom in and zoom out. And this one is the full screen control. It doesn't work on Google Collab. So you can ignore this one. This one is draw control. So allow you to draw things on the map. For example, here, you can click the button. You can draw, oops. This is just a rectangle. So you can draw things. Or you can do this. So this can be helpful if later you want to filter the data, get some imagery. You need some bounding box or ROI. This can help you. Upper right corner here, this one shows you, for example, the layer control. So you can turn the layer on and off. Also, there's a button here, upper right. So if you click, it will show you some of this button here. So this will allow you to, for example, change the base map and do some other stuff. We will cover that later, but for now, just like in general, this is what the map looks pretty basic. It's OpenStreetMap, and we're going to load Earth Engine data on top of that later. So that's about the creating the map, and then you can start adding base map. So if you go to the next section, adding base maps. So for the base map, there are lots of base maps available. So right now, for example, but this one is using the Esri base map. So you can click. Can you see this one? The Esri base map. So just go to the section and then just click the button to whichever you want to try. You can also, after you have one base map, you can also add another base map. So m.add base map is going to add the map. So think about here, if you click this one, you're going to add the base map to the map above. So we are creating all kinds of maps. So the map object refers to the map. And if you run something, you will modify the object above. So I can add another one, for example, open topo map. You should see the map being updated above. So this is how you can add something. This is not Google Sensing yet. This is just web GIS. You put in the data from the web and load it on the map. And you can have upper right here. You can have this layer control to turn the layer on and off. You can also change the opacity. So there's a slider there. It's not super smooth on Google Collab, but you should be able to see it changed the opacity. So this is how you add the base map. And if you want, you can create an empty base map. So the easiest way would be like this. So let me remove everything. Just gmap.map and then just type the map object. It will create the default base map. Then in the upper right corner here, click this button. And the first icon, the second row, first column, if you click that, it should pop up. This one allows you to change the base map. So there are hundreds of base maps available. So you can change to whatever base map you like. For example, terrain, cattle, dark matter. So there are hundreds of base maps available here that you can make changes. For example, Esri Street Map, NASA, Open Base Map, USGS. So these are all the freely available base map from web services. Yes? No, you mean for this base map? Yeah, no, from all over the world. This is not Google Sensing. This is just makes it easy for you to get the base map. So Geemap built on top of other packages, so provide a list of freely available base map from the internet. So you can change whatever base map you like. If you want to use it programmatically, all you need is just the name. Remember the name and then just m.add base map, then you add the base map to the map. Any other questions? Okay, so next, I'm going to go to the Google base map section. So you can run this one. If you want to add the Google map, for example, Google hybrid base map, you can use these 2 lines of code to do that. We used to incorporate this one in the drop-down list, but since Geemap has been officially adopted by Google, now we have to follow the term of service. We are not supposed to use this one on the official Google product because you need the API key. But for this workshop, or for your own, and you use it at your own risk, but you're not supposed to use it for commercial. But Google is making that link available, so you can use it. They're not limiting people to use it, but you do need to be careful if you're using it for commercial. But for training, for workshop, it's fine. So if you want to add Google base map, here are the 4 links: raw map, satellite, terrain, hybrid. So for this one, right, we're using the hybrid. The hybrid means the satellite base map and also the label. But if you want, you can change it to other stuff. For example, if you want to load the Google map here, you can copy this link, Control C, and you just replace this one here. Replace the URL, and then if you run the code, it should load the Google map. See? So you can use those Google base map services. Again, it's free for non-production use case. If you use for production and commercial, you need to pay the license. Yes? No, you don't need to. So if later we create another one, it will be overwrite. It will overwrite. This one will not be accessible. So right now, for example, here, right, we have this. Say it again. This one? Yeah. You don't need to close it. You don't need to close it. If we were trying to display it, if you don't write this line, you just run the code because you're not displaying the object. It will not show you anything. So the map is just to display the object, display the map. Otherwise, just you don't display it. It's just in the memory. So we need to see it. That's why you need to display. So whenever you display the map, it's a map object. So you want to show the map. So you can display in multiple locations. So this is one. I can actually create another one. For example, here I can display it again. See, the nice thing about this, that object is the same object. So if you zoom in on one map, it should zoom in on other map. So pay attention here. Oh, Google Map, Google Collab has an issue. It basically, it should be synchronized. If you do that in locally, it should be synchronized. But Google Map basically is not. Okay. Yeah, if you don't type this one, it will not display the map object. But you can certainly close it. If you close it, then it will be gone. So for example, dot close. Oops. It will disappear if you close it. That means it's destroyed, so it's not in the memory anymore. And yeah, that's pretty much it. And here's the, if you want to add the base map selector directly, it will show up in here. So you can change to whatever base map that you like. Some of the base map may not work. It depends on which one you select, but at least you have, I think 150 base map allow you to choose. So that's about the basics, about creating a map and then add some base map layer. You can also add some web services, WMS, XYZ type services. So there are some of the standard web services that you can load to the map. And again, those are just basic stuff. It's not Google Sensing yet. So the next section, we're really going to get into Google Sensing to see how we stream the data from the cloud and then visualize that. So go to this one here, the layer manager, and just click this code block and run it and see what do you get. So you should be seeing a DM and also the US state boundary. So right now what we're seeing, this is from Google Sensing. This is cloud computing. We're pulling the data. And so let me quickly explain here, what does it mean, right? So the first line, simple. We create a map centered around the US, zoom level 4. And for all the Google Sensing stuff, it starts with EE doc something. That's why we, at the beginning, we import EE, basically we bring the entire library. Then you can start reference all the object within here. Just like if you want to attend this workshop, you need to come to this room, right? And then each of you is like, it has a unique identifier. So this one here, this one will be the unique identifier. Think about the social security number. Every data set in Google Sensing has a unique identifier. So you just need to point to that. And depending on whether it's an image or it's an image collection or visual collection, I will talk about more in detail later. But for now, just think our image is just a single image. A visual collection is an HZ file, but it's in the cloud. So it's a vector data set. So visual collection is a vector data set. And again, this is a unique ID. So this one will be the tiger, the state boundary. And you need to figure out how you want to visualize the data. So this is for the DM. So the minimum is 4,000 meters. And this is the color palette. So the color palette basically means the color rank. Just like in desktop GIS, you open the raster and then you go to the property and then change the symbology, select the color rank. But for Google Sensing, you need to define those yourself. There's an easier way to do that, but for now, just think about this is the hex color code, 6 digits. The first 2 digits is a red, green, blue. So it's hex color code, so it looks like this. So where's the hex color code for red color? Anyone know? It will be FF0000 is red, right? RGB. So F means it's 250, FF is 255. 00 means 0. So 0 to 225. Okay, so the color looks like this. This is how you can do this visualization. And then just call m.add layer. So basically, you are reference to that data set and then you want to load the data. Kind of like in desktop GIS. You drag the data or you click the plus button, you add the data layer. But we are doing it programmatically. So we add the DM data layer and then we add the US state. So all the function basically means if you hover your mouse on the function, it should pop up the help documentation here. So you can see the first one, the first parameter is the object. The second one is how you're going to visualize that. And the third one is the layer name. What layer name? So the layer name is the one I'm going to show up here in the layer manager here. And also you can, by default, you can choose the opacity, or you can the visibility, something like that. And the last one is add the layer manager. So it shows up here directly. And this is how now you can turn the layer on and off, right? Here. And you can change the opacity. Just like that. So you're loading data from Google Engine and then you are changing the color. So this is how you visualize image and also vector data. So let me show you how easy to make changes, right? So assume that, okay, I don't want this color. I want a better color. You can change it easily. For example, remove this one and then just double quotes, type terrain, just a single string. What happened? It should not take this long. It should be just seconds, right? So see the changes? So you can use matplotlib color map. If you don't familiar with the package, is fine. So here, look at this. You can zoom in, you can zoom out pretty easily. So changing the code. Also here, because this is the global DM, right? What's the maximum elevation on Earth? 8,000 something, right? Because they're using 4,000, so anything greater than 4,000 will be like pretty much in white color. So if you are focusing on an area that has high elevation, you probably need to change this one. So this is in desktop GIS, you set the minimum, the maximum. So I can, for example, change it maybe to 6,000. See what happens. And now if we move to here, it looks better now because you stretch it. So this is just basic GIS cartography. How do you change the stretch, the value, minimum, maximum, and also change the color? You can change it to any strings as long as it's supported by matplotlib. So if we want to see what it looks like, matplotlib, matplotlib color map. Like all kind of color like this. You can search it if you want to. So this will be all the colors. So any of those strings, you can use it over there. So for example, is there the terrain somewhere there? I forgot, like the terrain, right? This one here. You can use anything, jet or rainbow, whatever you like. So for example, I can come back to here. This one, I can change it to JAT. Run again. Right, so you can customize, you can change it easily. So there are lots of options available for you to visualize data. Depends on whether it's DM, is it temperature, is it all kind of stuff. We'll show you more examples later. But this is the most basic thing of using Geemap is to pull the data and then think about how you're going to visualize that. But you don't have to download the data. You can point to any data set available on there. Next one, inspector. So for this example, I'm going to load the DM. Also load the lens set data and also the feature collection, the vector data. And this is how I'm going to visualize that, add data layer, add layer. So you need to basically do it programmatically. So for every data set, you need to point to the data and then load it to the map, right? So here we have these 3 data set and you can turn the layer on and off. Right? We have the DM, global DM. We have the DenSet global mosaic. We also have the US state boundary. And the Act Inspector, that means this one here, lower right corner here. And so you can hover your mouse on the map. You can click on the map. It will query the data. So here you should be able to see all the pixel values. If it is raster, you're going to see the pixel values. For vector data, you're going to see the attribute. So I can click the plus icon. You can see all the attribute here. So for example, if I zoom in to maybe Texas, right? I can just click here on Texas. And you should be able to see all the pixel values and also here. And this is the same like the desktop GIS, the identifier. Identify the pixel values or identify the feature intersecting with the certain feature. Although right now the color doesn't look good, right? It's like a very dark. We can customize it later. For now, this is what you can do. If you really want, I can show you here another example, see how we can customize that. So for the next code block, right? So this is the DM. And if you don't know how to visualize that, let me do it like this. Okay, just to show you from scratch. If you know the data set, And let me remove this. So if you want to follow, you can remove the code block. So I'm going to make a simple use one. So where assume that you have no idea how to visualize data, but you know the unique identifier. You know this person. Okay, I want you to help me. I want to use your data set, but I don't know how to make you look good. Then you can just add whatever you have. So pointing to the data set, and then if you don't know how to visualize that, you just put in the empty curly brackets. That means I have no idea what to do. So run this one, and let's see what happens. So this will be the default one, right? It's just using the grayscale. So this is the DM, and this is just the empty curly brackets that we don't specify how we want to visualize that. So once you load the data, right? 4 lines of code, right? You can understand this one, right? We're creating a map, we're pointing to the DM dataset, and then we load the dataset on the map, and then we display the map. That's it. We haven't said how to visualize that. So once you have this, you can go to the upper right corner here. No, go this one, the data layer here, and there is a button, a settings button in the middle. So if you click this one, it should pop up the layer here, the layer editor, and from here you can drop down. You can select the color map that you like. Okay, so I'm going to select the one. For example, I'm going to select all the way down terrain, and you click apply. You see? So now you can change the color, but again, this look all white color because the maximum here is only like default one is only 100, so it's too small. Anything greater than 100 is the white color. So what you can do here is double click on the right here, double click, and then change it to whatever number you like. So for example, I can change it to 4000, and then just hit enter. Apply again. See? Easy and quick, right? And just like desktop GIS, you can make customization. Again, if I move around here, if you focus on this area, it's still too small, and then I can change it maybe to 6000. Hit enter. Click apply. Better, right? You can change it to other color. For example, you can change it to maybe prism. Well, this is probably not very good for elevation, but you can change it. So basically, there's no coding. You select whatever you like from the maybe twilight. Right. So you can visualize any data set. So all you need to point into the data. If it is a single band, then you can use the so-called color palette to change the color. And if you see from there, right, there's not much you need to do. You just load the data layer. Just say, come, I want to use you, and then I'm going to put some makeups on you to make you look good. And once you have that, all you need to figure out what's the experiment, and then figure out the minimum, the maximum, and also the color palette. And then you can go back to use the sample code, just like what we did above. Just fill in the information in here, and then load the data. And then put this one in the parameter, replace the curly brackets. That means now I know how to visualize it, and that's it. So this is for single band data set. You can also visualize multiple bands. So similarly, I can load this data set in here, and when you pull up, you can change the band combination. So this is just the force color composite, but we can also do RGB, for example, 3, 2, 1, apply. All right, and you can change it. So everything is being loaded on the fly. So we are requesting the type. We tell the Google Sensing Server what do we want, and then we render the data, and then we send back to your client so we can visualize that easily. You can change whatever combination you like. For example, 7, 4, 3, apply. Right, and you can change it to whatever color you like. If it is too dark, then you make the value smaller. If it is too bright, you make this value larger. So basically, you stretch it, right? So for example, right now it's 200. I can change it to 100. Apply. It's expect a little bit brighter. Oh, it's still not that bright. So maybe 50. This is probably too extreme. It's still, yeah, okay, not bad. So you can customize. You can change it to whatever you like. So this is for multi-spectral band. And yes. Okay. Yes, so there's actually an import button here, but probably that you can see that at the bottom here. If you click the button, and then you can copy. Ideally, in the past, you can actually add that one as a code block, but Google Colab has limitation. So what you can do here is it look like this. Copy this one, and then you can come back to here, have this one as a parameter, right? And so what you need to do is just to replace this one with this variable, and then run it. Then it should be customized to whatever you want. So there's an import button. Similar in here, you can see the color palette. So you can customize it to your liking, and then you can get the code snippet, and then you can pass it back to the program so that it's like precise exactly what you want. It's reproducible. So, and for this one, it might be too long. You might want to just use the name. I think this one is probably, I need to fix it. It should be using this name rather than the long. So basically, it's taking the name and then expand it to all the hex code, but it's probably too much. So just use palette and then double quotes, and then get the name from the drop-down list. Okay, any questions? So that's about the image. So the last example I want to show you here is feature collection. So this is vector data, and by default, it's going to load the data. So again, it's only like 4 lines of code pointing to this feature collection, and then edit. So again, I don't know how to visualize that. That's why I use the curly brackets and give it a name. You don't really need this line. This one is just to show you this one by default. But if you don't have that, oops. I'm going to run this one just to show you, like, just load the data, create the map, pointing to the data, load it, and it looks like this. So if you want to change the customization, again, there's a settings button here. You can click this button, and we can start changing it. So, for example, the outline color is red. I don't want the black. I want to change it to red color. You can click it, change it to red. And if you don't want to fill the color, you can make the fill color opacity to 0, and then just click apply. See what happens? So you can customize basically the visualization of the vector data, and you can also make it slightly. For example, the fill color, I can change it maybe to blue color, and maybe half transparent. Apply. You can play with that. Again, don't worry about that. It won't break things. Okay, the code block might break, but you will not break the server. You will not break things. It's just like for you to visualize. But if you're using desktop GIS, sometimes you might be like, oh, do I modify the data if something goes wrong? Don't worry, everything is just like temporary. You cannot modify things on the Google Cloud. You're just doing the rendering, doing the visualization. So all kinds of things you can do here. You can change the thickness. For example, change it to 5. Apply. It should become thicker. So, and similarly, after you're done, you can click the import button. It should give you this, the style. And then you can go back to change the style. The only difference is that, let me show you here, okay? I'm going to copy this one. And then I'm going to come back to here. Just replace this one. And so you cannot just put the style in here. For vector data, it's a bit different. It's actually applying here in the data set. And then dot style. Okay, there's a function. And then parentheses. And then double star style. Okay, it's a bit confusing for beginners, but this is what the Python programming, like the syntax. So double star means you unwrap the dictionary and then put it into something, change it to something equal to something. So you'll be color equal to blah blah, something like that. So if I run this one, you should get the same result, just like what I'm doing in there. So you can basically figure out the visualization, and then you can put it back in the code block. Again, just load the data, then use the editor to change the visualization. Get the code snippet, and then put it back into the code, and then you can do create a map exactly like what you want it to show. Questions? So that's about the visualization, and the last one I will show here before we take a break is the draw control. So for example, I can create a map, right? So this is, for example, the global DM, and if you're working on a particular area, you just want a small area, but you don't need the entire one. Then you can use the draw control to create an RI. So here, I can just maybe click this one and then draw a rectangle somewhere here. For example, I'm studying mountains. I want to just this area. You can click this one and then just create this one. So for this one, it's basically after you create the object, you can access things you create on the map. So the m.user RI, you can run it. It will show you the polygon. So basically everything, think about the map is just like Lego. You can refer things on the map, whether it's draw control or the bounding boxes or the coordinate. So I draw a rectangle. So that bounding box rectangle has all these coordinates, basically the 4 corners. So you can actually get the coordinates. But the reason we want it is like we want to clip the imagery to the region of interest, right? So you need to get the coordinates. So this one allows you to do that. So what we are doing here, if you draw something on the map, if your user RI is not none, I'm going to clip the DM. So the DM refers to this one, right? The DM is just pointing to the image. So clip, just like in ArcGIS, right? You use the toolbox and then you run the tool like extract by mask and then provide the input. Same thing in here. And if you run it, go over here, see? I clipped the image, right? So it's all the data are temporary. I don't need to download any data. I don't need any space on my computer. It's being running in the cloud. So after, for example, I clip and then m.layers, number one, basically hide the global base map, set the visibility to false, and then we add the subset of the base map. And this is exactly what it's about. Again, you can go back, for example, you can run this code block again, okay? And so, for example, right now, I want somewhere, for example, okay, I want the data for Texas. I want to get the DM just for Texas. You can get the US state boundary from Texas. I will show you in the next section. But for now, right, I can just do it roughly, for example, somewhere here. Okay, assume this is what I want. Click this one, load the map, and then run the next code block. Okay, oh no, this one. See that? And take a look. Did I change any code? Not really. It's the same code block. I didn't make any changes. All I did is interact with the map. So this is the power of using programming, is that allows you to create things and then they only need to change things very minimal. You can get the new result. If you're using desktop GIS, you need to load the data, you need to run the tool, you need to save the result, you need to do it repeatedly. But for this one, I can create individual DM for the entire US, for 50 states, 2 lines of code. I can iterate through that, and then I don't need to really do it manually. I don't need to select the input and then 50 times on ArcGIS, click through. You can do it programmatically, and it's the same line of code. You can do it by country. You can do it by state. You can do it by county. It doesn't matter how many numbers you have. It's going to be automatic. So if you know how to do things automatically, it's going to increase your productivity a lot. Okay, so that's about the basics. Creating a map and loading some data, image or feature collection. We have a lot more to cover, but maybe let's take a 5 minutes break, see if you have any questions, and then get some drinks. We come back maybe at 9, maybe at 10 o'clock, okay? Let's have a 7 minutes break. All right, so let's continue. And so in the previous section, we have learned about how to create a map, authenticate Google Sensing, load some data. And the next section, I'm going to show you, dive more into the Earth Engine data type. So Google Sensing has 1, 2, 3, 4, 5 major not really data types. So basically it's raster data and vector data, similar to what we usually deal with in desktop GIS. So image basically is just a single image, right? A single length image. Image collection is a bunch of images, and the image collection contains 10 images, 100, 1,000, a million. It doesn't matter. It's a bunch of images. Think about you have a folder on your computer that inside has a bunch of images. So the entire Landsat archive, Landsat 9 service reflectance can be one image collection, and inside the image keep updating. So image collection basically is a bunch of images. Geometry is just like the shape, just like the Esri shape file. You have the geometry, And a geometry with attribute attached to that becomes a feature. When you have a bunch of features, then become a feature collection. So this basically is just a vector data set in Google Engine. And so feature collection, you can see this the entire shapefile file. The US state boundary, for example, a feature basically is just one row in the vector data set. For example, there's Texas. Like you select one row in the desktop GIS, right? Geometry is just the shape, the coordinates. There's no attribute associated. So when we are doing some data processing, sometimes we need a geometry, sometimes we need a feature collection, depends on the application. If you just want to do the clipping, right, you don't really need the attribute, right? You just need the shape. But if you need to calculate some information, sometimes you need the information from the column. For example, you want to calculate the total population of the entire US. The population comes from each individual state, then you need a column, then you will need the feature collection. But essentially, this is raster data set. This is vector data set, and it corresponds to the traditional data format that we have. So next, we're going to go quickly. We're going to move faster because otherwise we don't have time to cover the cool stuff. Right now, this is still the most basic one. But like I said, Google Engine is basically anything start with E. And earlier there was a question like, how do I know like what to use? Google Engine is the Python package, so you can just type E and then doc something. You will see all the things available. So it can be e.image, e.image collection, e.feature collection, or blah blah. And this one right now we are referring to an image, and you can just print out the object. So you should be able to see all the metadata information. So if you are interested in using any data set, you know the social security number of that person, but you don't know what they can do, what they have. You can just show me what you have. It's just type the variable, and then you show you all the information that it has. How many bands in there, what kind of property, this information, and you can go to the links. So this is basically similar to the, if you go to the Earth Engine website, the data catalog, just like what I showed you earlier, you can see all the information for that data set. So you can refer the data set just by printing out the variable name. Oops, where exactly? Oh, I think I skipped it. I skipped the section. Oh, I forgot this one. Let me go back to this one, the data set, source data set. So let me cover this one first, and then we can go to the data type. So how do you source Google Engine data? So here, all we need is just create a map. That's it. And then just map doc something. Once you have the map, upper left corner here, on Google Collab, you can click the button. And on the search tab, you can source data. So this is the very convenient feature that allows you to search any geospatial data from the Earth Engine data catalog. Just like you go to YouTube to search video, you go to Netflix to search video. So here I can just search anything I like. For example, elevation, and then hit enter. You should see all the features contained, for example, keywords elevation or relevant to elevation, right? And you can scroll down, right? Pretty nice. I don't really need to go online download data. So all the data, basically, we can just load the data directly. Here, for example, NASA SRTM digital elevation model. You can select whatever you like. Click this one, and you're gonna show you the information. So the most important one will be this one, the unique ID. So it's gonna show you whether this is an image or is an image collection or is a feature collection or anything. And this is where you refer to the data, right? So you can just have a variable equal to this one and then print out the variable, you can get all the information. But a better way of doing this is just click this button, import button, and you will see the source code here, and it has been automatically converted from JavaScript to Python. So all you need is Control C, right? And then come back to here. I think I need to fix it. Right now the variable name is not right. So, but this one is using the uppercase M. You can change this one to uppercase, or maybe change this one to lowercase. Maybe change it all to the lowercase m, and then you can just run the code. You see, I'm getting the DM. So I think previously the convention, the variable name convention was uppercase map, but now we have changed to lowercase. I haven't updated the code base to do that yet. So just change the m dot blah blah something to lowercase. Then you should be able to load the DM, right? So here I have the slope calculated from the DM automatically. So you can search any data set you like, and you can load the data. So for example, I can come back here, I can do this way. I can maybe just say lane cover. If you want some lane cover data, so here, scroll up, for example, Copernicus, blah, blah, ESA, for example. I want to use the ESA global lane cover. So you can click this one. Oops. Make sure you click this button, otherwise when you your mouse is moved, it will disappear. So let me click this. Search again, lane cover. And I'm going to select, for example, the ESA world cover, 10-meter resolution, global scale. So this one here, take a look, right? This is the image collection. So image collection, that means there are multiple images inside there. And again, click the import button, and that's it. Now I can just simply copy the code block, Control C, and then come back to here. So like I said, this one is using the uppercase. So you can either change this lowercase m or you change this one to uppercase map. Either way is fine. So I'm going to change this one just to lowercase. Run the code block. Okay. So now I have the global lane cover, 10-meter resolution. Good luck if you're trying to download it. It's going to take you hours to download all the image tiles. But right now it's a global mosaic and easy. You can zoom in, for example, here, right? Houston. See the lane cover. You can later I'm going to show you how to add a legend to the map, but this is essentially how you search any data set. 100 petabyte in there. Search whatever you like. Get the code snippet, paste it, run it, you get the result. You never have to really download. You can run computation easily on top of the data set. So try it out. You can also do it this way. I'm going to skip this section. It's not very popular that many people don't know, but if you want, you can use it. So next, let's go to the data type, right? So image collection, feature collection. So you can refer to any data set. Also, here, for example, this is an image, e.image, right? So you have this one, and for every object, Python is an object-oriented language. So every object, you can apply things to it. So how do you know what kind of things you can do? For example, I want you to help me do something. I know you have something, but I don't know what you can do, right? So it's an object-oriented language. You can just type image dot on Google Collab. It should automatically show up the list of all the functions, all the methods available for that class. You can see this is a huge, long list. So every object, cloud object, can do something. You can do computation. You can get some basic information. So for those of you who really want to learn this very well, I would recommend you go to the Earth Engine webpage. So here, let me zoom in a little bit. So go to the Google Earth Engine website, and then the platform. Then from here, documentation. There's a so-called reference. So for programming language, there's always so-called API reference. This is going to show you what kind of things are available for each object. So on the left side, client libraries. And so if you're talking about e.image, these are all the things you can do, apply to an e-image, right? So earlier I showed you how to do the clip, how to click the image. So if you click this function, you should be able to see the help documentation. What kind of things you need to provide to apply the function. You can also do clip to image, clip to collection, for example. And you can see the sample code in here. You can use JavaScript or use Python. But if you use Python, basically it's use Geemap. So Geemap has been officially incorporated in the Google Earth Engine documentation. Here you use the Geemap.core. You don't need to. You just import Geemap, and then you can get all the information just like what we are doing here. So for example, I can copy any code snippet, and then I can come to here, and I can just replace this, put inside, run the code. Okay. All right, so you clip the DM to a country or whatever, or you have feature collection, and you can do a lot of cool things using this. We don't have time to go into all the details, but if you have time, go through the documentation, know where, because this is API, so what kind of things you can do is all documented in the API reference. Okay, so that's about the image. The next one, image collection. So image collection. So we're going to use the Copernicus Sentinel-2 harmonized data set. So basically you have Sentinel-2 and 1, so it's 10-meter resolution. And this just one single line contains tens of millions of images in there. Just one line. So you're pointing to all the images that have been acquired by Sentinel-2. And you're just pointing to this one. So this will be just like, analysis will be like, I want people in the state of Texas, all of them. One line of code, you can refer to the entire population. And you don't need to really know. You can, after that, you can filter, you can get some images. You can, I don't know how many images in there, but certainly there's a lot. So, for example, you're pointing to the entire collection. Then you can print out the first one, for example, just collection. So, first, and you get the first imagery. So you can take a look at the metadata information, because all the images in this collection, they are very much similar. So they all have 26 spectral bands, so all the images. And also you can see all the properties of this. So basically this one line of code has everything you need. All you need to figure out, what do I want, right? You have all the images covering the entire globe. We can later filter, for example, I only want the images covering Houston. I only want images for the summer season for the last 5 years. Just 2 to 3 lines of code, you can get all the images you want, and then you can start doing computation or doing all kind of visualization. So next, let's think about how do we filter. So kind of similar to desktop GIS, select by location or select by attribute, right? So if you go to NASA website, you want to download images for your area of interest, you need to figure out the coordinates, or you have a bounding box, or you need to upload a swap file or anything, and then use that to do the filtering. You can also filter by cloud cover, you can filter by all kind of things. So loads of things that you can select by location or select by attribute. So the first one I'm going to show you here is e.geometry.point. So basically we are constructing a point, and this is longitude, latitude, and we are going to use collection.filter bounds. Filter bounds means, okay, give me all the images that covering this location, intersecting with these coordinates, and tell me how many images in there. So behind the scene, it's going to filter the entire catalog. See how fast it is? It can quickly tell you, okay, have 863 images covering this location. And you can change this one to any location you like, as long as you know the latitude or longitude of the location. And it's going to show you the 800 images. And then you can show the first one, right? So we are filtering the images, showing the first one. You can see the information, you see the cloud cover, blah, blah. A more comprehensive example would be like something like this. Select by location, select by time, basically select by spatial and temporal, right? So passing the geometry, the same point, and you can tell, okay, I only want one image from the summer season, right? So filter date, and then you're passing the start date and the end date. The end date is not included, so it's excluded. So that basically means we are getting imagery from July, August, and September. And you can also specify cloud cover pixel percentage less than 5%. So this one we are filtering by attribute, right? So every satellite imagery cover a certain location acquired at a specific time. They also have a bunch of attributes. For example, cloud cover, or the acquisition time, all kind of stuff. So how do you know this one? For example, how do you know this like cloud cover percentage is actually from here? So if you just show the first one, right, they are all consistent. And if you take a look at the property, all these property can be used to do the filter. So we are only utilizing this one, for example, cloud cover percentage. So this particular image has 66% cloud cover. That means it's not good quality imagery. And that's why you can filter. Basically, you can have a bunch of criteria to filter the data to your need. So right now, oops. For this one, see how many images? Right, we narrow down to just 5 images, right? So there are 800 something images cover this location, but there are only 5 images that cover this location this summer with cloud cover less than 5%. So we are trying to select the good quality image for a particular location. So once you have the images, now you can see these are all the standard ones that we have used, right? Out of those 5 images, I just want to get the first one, and this is how I'm going to visualize that, add the data, and then load the map. So run it and then see what happens. All right, so I'm getting image covering Knoxville, Tennessee. Although the color might be a little bit dark because probably this one is like too high, you can change it to a smaller one, for example, maybe 2000. Then it should become a little bit brighter. You can also change the band combination. For example, you can change to other band combination. So those are the ways you can do that. For example, I can click this button here and upper right, I can change, for example, to B8, 4, 3, apply. Okay. So this is how you can get data, filter the data. You can change it to any other location you like. For example, right now I can show you on the fly. How do I get a Sentinel-2 imagery this summer covering, for example, Houston? All right, I'm gonna come here. I don't know where exactly. Are we somewhere here, right? Okay. So all I need is just place a marker here. I don't know the coordinates, but you can easily do that. And then just create a new code block. And I can just mdoc user RI. I get the coordinate here. This. Control C. Come back to the code block here. And pretty much this one. Replace this. Then it becomes Houston. So let's see how many images, Sentinel-2 images covering Houston. This area, 878. And we continue to filter. Everything else remains the same. There's minimal changes, right? I need to change coordinates. Now let's see how many images. Only 2 covering this area. They meet the criteria. Cloud cover less than 5%. And then, see? Right? See how easy it is. So this is really helpful because in the past, if you do data from one area and now I need to maybe change to another area, you need to go download the data, you need to redo it, you need to redo everything. This one takes you 1 second. Just change the coordinates. It doesn't matter what you do, the workflow is still the same. So in that way, you can focus more on your algorithm, focus on what you want to do rather than, okay, how do I manage the data, how do I download the data. There's no data storage. Everything just one line of code and then you can get the data you want. So you can, yes? Oh yeah, I will show you how to download. For now, it's just like computation. You can run all the computation, for example, do all the mapping, classification, and then get the result out. But you certainly don't want to download all the original data. Then you lose the purpose of cloud computing. Kind of like you watch a movie on Netflix. You like the movie, you want to try to download all the movie, keep a copy. It doesn't really make sense. The point is like you want to do the streaming, right? But it certainly allows you to download some data. I will show you later in another section. So try this one for any area you like. It can be any area around the globe. It doesn't have to be US because it has global coverage. So you can get tons of images for your area. So for example, this is just like right now, for example, there's one imagery, but you might have, for example, right now this one has 2 images in there. I can just create a median. You can actually combine all the images together and then it's a single image. So for this one, I can just do median. And this is what happens. You can combine, oops, non-type, what is this? Non-center. Interesting. It's supposed to combine all the images. Anyway, I'll show you more examples later. So for this is how you can easily create. Actually, it's here. This example. So this one. Okay, yeah, this one works. So all the images, create a median, and then so earlier you only see one small slice, right? Because you had 2 images, it combined the 2 images together. Using a so-called median. Median means you take the median pixel. You can also take the average. You can take the maximum, depending on what you want. So later I can show you, for example, how to create the global mosaic together, just with a couple lines of code. So here, maybe right now I can show you. I think I have examples later. Maybe I keep it later. So this is how you can quickly, for example, find images covering a particular area. You can reduce the cloud cover. For example, I can change the cloud cover maybe to 10%. If you end up with no images, your criteria is too high, you relax a little bit. At the end, you will get the images that you want. So, and see this? Pretty good, right? So I don't need to spend time to download images. So for image itself, this is 7 GB, each of those. You're going to take you a couple hours, not couple hours, but maybe 20, 30 minutes just download the data. But now, seconds, I can visualize any data, any location around the globe without having to download the data. It can be Landsat, it can be Sentinel, it can be anything from that 100 petabyte data catalog. So that's about the raster data. So next one, let's talk about vector data. So here, I'm going to point into the feature collection. So this is US Census rows data set, and basically pointing to the data, and just load the data layer and zoom in, zoom out. Take a look. This is the entire US, transportation, all the road network. This is a huge data set, and you will see it's going to take time to load up because it's fetching the data and then render it. The color might look like super nice, but here I can come to, for example, same thing here in Houston. So you can get any data you like. Either it's raster data, vector data. I will show you how to do some visualization later, but all you need to figure out what do I want. So for data, you can filter by location, you can filter by attribute. For example, I only select data, I don't want data about the interstate highway from this. All you need to figure out what kind of attribute this one has. So similar to the example that I showed you earlier, right? This is the entire collection. So what you need to figure out is what kind of column. So think about this in an Azure shapefile. You need to figure out, if you want to select by attribute, what kind of column it has. So what you can do is just simply fc doc first, run it, and look at the property, right? So they basically have these 4, and there's maybe RTT type or something. That one has the row type. Although this one happens to be empty, maybe just a small row or something, but there should be other attribute. So you can do the filtering. I'll show you more information later. But so how about this? There's a US state boundary, and if you need to filter by location, you'll be like this: e.filter, the collection filter, and then e.filter.eq. EQ stands for equal. So what we're trying to do here is like, if the name equal to the Tennessee, I'm going to select that, and then I'm going to add the data layer. So take a look. So now I can get the boundary. So this is how you can easily filter vector data. So for example, how do I get Texas? Simple, easy, right? The name equal to Texas. And now we have Texas. So then you can use this one to filter the entire collection. So we can use this one as the region of interest to filter the entire Sentinel-2 catalog covering the state of Texas. And then you can quickly create a mosaic just with a couple lines of code. And you can do, for example, look at the information, like what kind of columns, attribute information for that particular feature. You can also convert this one to a data frame. So if you want a table, so this is kind of similar to desktop.js, E to DF. So think about all the Google Sensing data is in the cloud. So it's called server-side object. If you need to get it to the client, then you need to open it. And once you get to the client, it's not cloud computing anymore. It becomes a local data set. Then you can use cloud computing. So here shows you, for example, this will be the attribute table for the state of Texas, right? So basically similar to you desktop.js, you select one row and then you highlight that one. Or you can select multiple. So for example, I can e.filter.list. So this is the vector data, and then e.filter. Again, if you don't know what kind of things you can do, you can go to the client library, e.filter collection. And so in here, you should be able to find like the filter bounds, filter date, or something like that. So those are all the standard library, the functionality available for that package. And so I want to find out if the name is in the list. So if the name is equal to California, Oregon, Washington, I'm going to select, for example, you're working on West Coast, or it can be in the South, or it can be anything. So basically, this is select by location. select by select by attribute. Or you can do it like this way. For example, I'm going to select this. Okay, I want to do in the Southern United States. Oh, maybe not this one. Let's try this. So draw a rectangle, for example. Okay, I want to do some research in this area. I can just draw a rectangle. No rectangle, a polygon, right? Something like this. And then you can just use this one line of code. So if you draw the ROI, I'm going to use the ROI, and then I'm going to filter this one by bounds. Filter bounds basically is select by location, intersecting with your region of interest, and run this one. Okay, select all of them. Of course, it's not as intuitive as desktop GIS. You select and then you highlight them one immediately, because this is cloud computing. So the object is not on a computer. So what we're doing here, we need to get the coordinates, send back to the server, and then run the computation, figure out which one intersect with your regional interest, and then send it back. So we don't actually have the data locally. They can just click and then instantly show you that, because you need the internet. Without the internet, you won't be able to do anything, because everything is sending back and forth from the server. You need the communication from your local to the server, and then use the API, and then do the selection, and then coming back. So this is how you can do some data select by location. Questions? So beside the US state boundary, the Google Sensing also, for example, have lots of data, for example, for country. So in this case, I'm going to use the Landsat data. This is a global imagery, and you can filter data by state. For example, I'm going to select Germany out of that, and then you can use the clip to collection. So basically, you select Germany and then clip Germany to the image according to the boundary of Germany, and then just select things out, and you can see. So now we have the images. So this allows you can use a combination of filtering. You can change it to any other country, so it doesn't really matter. I can change it, for example, to France. Right. So now I have France, I have UK. For example, I can change it to Spain, and see how fast it is. Right, seconds. Rather than I get the imagery and then select this one, use desktop to clip, takes a couple minutes, export the data. This is no storage, no lag time, just change one thing, you get the result. So you can really do things for any location you like, any country, any location. You don't have to worry about storage or computation, because as long as your workflow is designed in a way that can handle different locations, then you can literally do things at the global scale without having to do anything. So basically, watch any movie you like on Netflix. Depends on your liking. It doesn't matter. TV shows, movies, and from the 1980s, from the most latest one, whatever you like, you just tell that, what do I want? Okay, I want to watch some action movies, or I want to watch some TV show from the old days or whatever. You just search, get the data, and then you can customize things to your liking. So this is how about filtering data, and also you can visualize vector data. I don't have time to go into all the details, but basically pointing to the data and load the data layer, and this is the default one. You can also use the style. I briefly mentioned this one earlier. So you need to basically maybe use the editor here to get the coordinates and get the code snippet, paste it back, and then use this one. For vector dataset is something called doc style, and then parentheses, and then passing the style. For raster dataset is within these curly brackets. So if you need more information, I know for beginners, it probably like way too much. Like, how do I know what to provide? The best way to learn is to go to the documentation. So if you go to the guides here, you're going to show you different data set, different data type, for example, image. And you're going to show you, for example, image visualization, how do you visualize the image. And these are all the parameters available. And these are all the, for example, the sample codes. And you also have the Python version of the JavaScript version. You can get the result easily. So you do need to spend some time to get familiar with kind of the syntax. But if you are lazy, just click the button and then just read through that. You can customize. For example, here, right now, it looks like this, but okay, I don't want the blue color. I want to change it maybe to yellow color. Then the color is being controlled by this hex color code. So this one is 8 digits. Red, green, blue, opacity. So the last two here is opacity. FF means fully opaque. You can change it to something else. For example, I change it maybe to 30 or 40 or something like that. That means it's going to be a little bit transparent. So you see the lighter blue color? I can change it maybe to yellow color. So what's the hex color code for yellow color? Yellow color is the mix of red and green, right? So it'd be FF00. Okay. So everything can be customized precisely if you know how to get it. If you don't know the field color, then you'll be here field color equal to, by default is red color. So the last two digits is 80, make it half transparent. If you want it to be transparent, you'll be 00, right? Okay. So it's very, very powerful, very flexible. You just need to know how to get it. So use those code snippets to help you get the visualization that you want. And the last example is customization based on a column name or something like that. It's a little bit more complicated. So you have a lot of things you can customize. The style, the width, the line, and the opacity, all kind of things in here. I don't have time to get into detail, but play with that. Again, you will not break anything. Worst case, it doesn't work. Then you need to fix the code. But it will not break your computer. So, okay, so that's about visualizing, filtering data, raster data. So by now, you should be able to get any image collection, Sentinel, length, and whatever, figure out your region of interest, and then just filter bounds. Okay, filter by the location, filter by date, start and end date, and then get a couple images, and then you can see it, right? You don't have to download the data. Questions? So next section, plotting tool. So this is also something that might be useful. If you're looking at the spectral signature, for example, for remote sensing data, right now we have this length imagery, right? So we're loading the data, also the Hyperion hyperspectral data. So those are white strips here. Those are actually hyperspectral data. So if you want, you can use the inspector tool. So this the plotting tool. So this is the one here, for example, and I can click your mouse on the map. You see the spectral signature of that. I think right now there's a bug on Google Collab. So if you click, it might pop up multiple. You might not be able to see that. I need to fix that. But for example, you can see different spectral signature. Oh, okay. So this is for something. You see, yeah, there's a bug right now. It blocked. It's not supposed to be. Okay, it goes back. Anyway, you can also switch different data layer. For example, Hyperion. So this one is hyperspectral. Right now it's showing a line plot and then with the dot, but you can change it. For example, how about this one? Change to a bar plot. So I can run this one, and then I can click here. Oops. It will show you the spectral signature. So this is hyperspectral, so it's over 200 bands. So you can click this. You can also add a marker cluster. It will show you the points available. And this is just for visualization if you want to use it. So you can set a bunch of options. Again, this is a little bit advanced, but just what I want to show you is like show you what you can do. Later, you can always come back to make changes or customize it to other data set. So that's about visualization. And the next one here, I can show you how to add some legends. So let me go to this one here. I want to add the NLCD land cover data set. If you need to add a legend here, just m.add legend. And so Geemap has some built-in legends. So all you need is just one line of code, add NLCD. It's basically this one. This legend here. Oops. But it might be too big, you can hide it. So in this way, you can see all the colors, what each color represent. So basically, it help you interpret the land cover type, right? So what's the red color represent? What does the red color represent? Urban, right? Developed area and agriculture, crop land, grassland, whatever. So certainly it has all kind of tools available for you to add the interpretation of the data. So the next core block here, this one is very much the same as the previous one. The only difference here is this one we're using the web map services, app-based map. So that means it's already rendered. It's not Google engine. So that one is basically for web service from the USGS. But for this one, we are utilizing the NLCD hosting on the Earth Engine data catalog. The nice thing about this, we can do computation, we can do inspection. So for example, this is the Landsat NLCD 2021, and we select just the land cover band because it also has other bands. And then we visualize the data. So here, what you can do is actually you can inspect the pixel value. So for example, I can click here, the icon, and the first icon, that one allows you to inspect the pixel value. So let me maybe hide this one a little bit. For example, okay, I don't know what is this. You can click. I'm going to show you lane cover 82, right? So what is lane cover 82? Let me show the plot here. Like cultivated crops, right? And you can select anywhere. Like maybe let me full screen. Okay, you won't be able to full screen on Google Collab, but I can full screen here on this one. So you can inspect the pixel value. So under the hood, you get your coordinates, send back to the Google Sending server, get the pixel value, and then send it back. So you need the internet. If there's no internet, you won't be able to get the result. And you can customize the legend. So if you're working on some customized lane cover classification, you can provide a dictionary. Okay, so this one looks a little bit lengthy, but the idea is that for the legend you want to add to the map, you can change it to whatever you like. Again, it's exactly the same because NLCD is very common. So I have the built-in legend, just NLCD. But if you have a customized classification with different color, you can edit yourself. So for example, this will be the label going to show up. This will be the color, right? So it's basically we are trying to add something like this to the map. So here is 11 open water. If you don't like open water, you just want the water, I can remove it, right? Here, run again. See water. So everything is customizable. You just need to know what do I want for that legend, and then you can use that to add this one to the map. So this is for categorical data, but for continuous data, for example, DM, temperature or something, then you want to use this one called add color bar. Add color bar allows you to add something like this to the map. So if you need to indicate, for example, the elevation changes or the elevation range, you can use this one, right? So here. And if you don't like this one, for example, just like what we did earlier, I don't like this customized hex color code. I can change it to any text. For example, double quotes, terrain. And that's it. You don't need to change anything else. The color bar is going to be created automatically based on this one. So if you run this one again, see here, it has been updated. So now we have this color bar here. You can also make it vertical. Right now by default it's horizontal. So you can specify, for example, the color bar is a vertical. So pay attention. 1, 2, 3. You see, change to vertical. You can also make it transparent. I'm not sure if the transparency works or not. Yeah, the transparent is not working. Never mind. So you can just customize whatever you like. This is just adding things to the map to make it easy for you to visualize the data. Next one, split map. So sometimes you want to create data that you can compare them side by side. You can doing something like this. Just one line of code, you can create something like this to, for example, compare the Landsat data and also the lane cover, or you can compare any data layer, like just one line of code. Super easy. And let me show you how to do this one. So what is this example about? We are pointing the data to the NLCD 2001 and also the NLCD 2021. And we're going to get the tile layer. So what this one is doing is I pointing these two data sets, give me the tile layer, basically the URL, and then you can put it into the split map. Just call this function, the split map, then we have this data here. And now you can zoom into any location you like. For example, this is the famous Las Vegas. Let's see how much it has grown in the last 20 years. Right? Yeah, the reservoir is kind of shrunk a little bit. Yeah, Houston. So you can come back to here. See what is. Yeah, it's certainly grown, but it's not as, especially in the northern part here. You can also turn the layer on and off, right? So for here, you can, for example, I can add a base map. So everything is customizable. I can just add the base map and then satellite. Right, so now I load the satellite imagery. And so let's look at Houston here. Pretty big, right? So for example, especially in this area, so I can turn the layer on and off. And then actually zoom in to take a look. Oh, nice. So it's not that complicated, right? 1, 2, 3, 4, like 7 or 8 lines of code. And again, this is, you can customize to any location. All you need to figure out what data do you want, and then get the URL, and then left and right, so you can create this split map easily. Just a couple lines of code to compare different data layers. Link maps. So this one probably doesn't work very well on Google Collab. So the link map is if you want to compare data for multiple bank combination, and so here it's all linked together. I think on Google Collab, if you check one map, it doesn't link to other one. So that's kind of the limitation of Google Collab. But for example, I'm creating Sentinel-2 harmonized collection for the summer, for this summer. Cloud pixel percentage less than 5%. And you can do basically lump divided by 10,000 for all the images divided by 10,000 and then create the median. So this one is at the global scale. You can actually go anywhere you like. So for example, I can zoom in here. Right. So these are all the images acquired during the summer. So now I can actually go to Houston. I can actually see it. Okay. So different bank combination, depends on what kind of things you want to study. You can highlight different features. You can zoom in. You pop out the high resolution. And this is the power of cloud computing, because the location doesn't really matter anymore. As long as you have the data, I can create mosaic for any location, for any bank combination you like. And it's the same line of code. You see here, I don't really need to make any changes. Of course, this one looks a little bit complicated, but the most extensive one is here. Pointing to the collection, filter by the summer, filter by cloud coverage, and then here it is how I want to visualize different bank combination, different label, and just one line of code here. Two rows, 2 columns. You can create as many rows, as many columns as you like. Next one, time series inspector. So here, I'm going to quickly run through this one just to show you what it looks like. So the time series inspector allows you to create maps. So have a drop-down list on the left side and another on the right side. Because for the NLCD lane cover, we have, actually right now we have annual lane cover. But for this one, you can actually change it to different years. So for example here, from 2001 to, oh, is it Las Vegas? No, this is Illinois. Here, for example, right, 2001 to 2019, but you can change it to other data layer, 2011, 2016, 2004. So if you have a time series of images, you want to compare them, this is also can be very useful. Again, it's a little more complicated than other examples, but most of those things are one line of code. So you just need to know what data do I want and what kind of tools do I want to use to visualize them. Last example, time slider. So this one is useful if you have a lot of images and time series by day, by week, or whatever. So this one is the MODIS NDVI index, right? So pointing to the entire collection, select just the NDVI band. This is how I'm going to visualize that. Then just call this function, add time slider, passing the collection, visualization and the time interval. So you're gonna have the slider at the bottom right here. Then I can drag through that. For example, here. You can also play it. Click the play button. You will just play, navigate through that. So this can be useful if you have a lot of images. It can be hundreds of images, thousands of images. It doesn't really matter. You will be able to do that. So this is NDVI, but you can also, for example, for temperature. See me in here, temperature. Like this is temperature within 24 hours. You can drag through that. So it makes it really easy for you to visualize time series data. The last one I want to show you here. This might be the most useful one. So if you need to find any images for a particular location, for example, I want to use Sentinel-2, and this is the location that I want. Cloud cover less than 10%, and I only want the images for the summer season, June, July, and August, and then give me all the images that meet this criteria. So here, for example, I'm filtering all the images for Knoxville, Tennessee. But I can change it to any other location. Just like I said, I can do it one more time here. Move to Houston. So if you are giving a task asking you to find all the cloud-free imagery for this location for the summer season, become a starting vegetation or trees or whatever, yeah, no problem. Just couple lines of code. Okay, find the location, whatever you like. It can be a point, it can be a bounding box, it can be anything you like, and then figure out the coordinates. So I'm gonna just m.user RY. Okay, get the coordinates. Find this one. Copy. Come to here. Replace this one. You can also replace here. And that's it. So now I have all the images covering Houston since 2019. And you can slice through it. If you want to figure out how many images, this one is a little bit cloudy. So if it's too much, you can change this one to a smaller number. And here it can show you, for example, it's a collection. You can figure out how many images actually meet the criteria. So you'll be collection doc size 47 images. So there are 47 images. So for this one here right now, I can just navigate through here, 47 images. You will see them, they're covering different area because in the set. But if you really want, for example, I want, let me show you what you can do here. How about this? Okay, let me show you how to do that. So for example, right now I want data covering Houston. Okay, I can draw a rectangle. I can maybe do something like this. Draw a rectangle here. Okay, and now I can similarly get the coordinates. So it'd be m.user user RY coordinates. This one can help you get the bounding box. You can get the lower left corner, upper right corner. So all we need to be something like this. Or I think you don't need the square brackets. So I'm going to show you here. I'm going to get this. And then you can just replace this one with geometry. So there's one called B box, bounding box. Parentheses, Control V, and that's it. So now I'm selecting all the images within this boundary, and you can do the same thing. This one is certainly going to get a lot more images, so it might be a little bit slower, but it coming up. Oh, it's on the left side because the bounding box is too big. So now we get a lot more images. So, but you can certainly get all the images for your area for the summer. Oh, this one is too cloudy. So the easiest way will be now we can create a virtual mosaic because you already have all the images. So all you need is basically collection. For example, I create the image equal to the collection dot median. So what this one is doing is taking all the images, do the mosaicing, and then you can add it to the map. So here, instead of adding a time slider, if you just want the image, you can do it like this way. You will m.add layer, and then just passing the image, and then the visualization parameters, and then it will be, for example, S2. And we should have the image covering the entire area. Think about how easy it is. Is it cloud free? Pretty good, right? So it basically create imagery for any location. You can also clip to it if you want to clip. For example, for this one right now, it's a little bit. It's not the exact area that I want. Simple and easy. Dot median and then dot clip. Right, and then inside here, I can grab this geometry that I created. Then it should be exactly within my bounding box. See, so now it's an exact bounding box. See how flexible it is. You just need to know how to get there. It's just like Lego. All you need is just to hook the pieces together and build the foundation, and then like doing some customization. You can display different band combinations. And this is nice imagery. But earlier you see that it looked cloudy, right? The reason why you don't see the cloud because every pixel location, there are multiple images available. And I'm taking the median. The median means usually because cloud is like really high value, high reflectance. And so median means not too high, not too low, not too high. It's somewhere in the middle. Usually it's pretty good quality imagery. You can certainly change it. So if I change it to maximum, then you're certainly going to expect to see some cloud in the imagery because you're taking the maximum value of all the images for the same location. Then you're going to pick up the cloud. See? Right? So it depends on what you want because you have access to all the data. You just need to know what kind of flavor do you want. Do you want like sweet flavor? Do you want salty? You just need to ask for it. So now this is like maximum pixel. For example, if you're doing vegetation study, you want to get the high maximum NDVI throughout the year or to this summer, then use the max. But if you just want good visualization, use the median. But if you're studying water, you might want the minimum, the mean. In that way, you will be pretty dark because you're getting all the lowest value, right? So now, see, right? Look very dark, and some of those like it might be water, it might be like cloud shadow or something like that. So in general, if you just want a visualization, the median is a pretty decent choice for most of the cases. And so try it out for yourself. You can get any data you want. You can choose any data set. You can run a combination. You can run the mosaic, not just for like right now we're doing it for Texas. You can do it for the entire US. It doesn't really matter. All you need is change the bounding box, right? So for example, it's going to take a little bit longer, but for example, I want to study, for example, the southeastern United States. I get this bounding box, and I get the coordinates. All I need, just this one, and then come back to here, replace this, and replace another one here, and run it. And pretty much, how long does it take? It's same, but the beauty is that right now, it's exactly what I want. You zoom in, you see, it's coming up, and it's all cloud free, right? Looks pretty good. Imagine how long does it take you to create like something like this if you have to like going to NASA or ESA to download the data yourself. This simple mosaic can take you days because you need to download the data. Once you download data, there are a bunch of images. How do you create a mosaic? You need the computation. But this, right? This is the beauty of using cloud computing because you don't have to worry about computation. I can do it for anywhere. You can create a global, right? You don't even need the location. I can create all the summer images covering the entire US. I don't need to basically if you don't like, I can just comment out this one entirely. Then it's actually grabbing all the summer images for the entire globe. And so in this one, I don't need to do the filtering. Remove this one, run it, and imagine how many images being involved in this case, right? So it's pretty quick, right? I'm doing here. This is faster because it's already case on your computer, but you can move to somewhere else. It should pop up. No? Okay, it comes up. Just a couple of seconds. You just need to wait. And you can zoom in, you can zoom out, you can do it for anywhere you like. So, questions? How much time do we have? 20 minutes? Okay, so for the next couple sections, I'm going to skip some of those. For this one is actually doing local data set, so I don't have time to go through that. But you're welcome to just run through that. So this one is show some example how to visualize data locally, and you can also convert data back and forth from your local computer to the cloud, and from the cloud to your local computer. So I'm going to go to the other section that will be useful for here. For example, I want to show you the zonal statistics. So if you go to the processing raster data and then zonal statistics, so this one is more like using analytic, because earlier we were just doing all kind of visualization, but the most powerful thing is actually allows you to run analytics. So I'm going to show you this example, like what kind of question can we answer using cloud computing. So here I'm loading the the DM global, and then I also load the US state boundary. So right now, if I ask you the question, which US state has the highest mean elevation? Colorado, right? You can see this like white color. Which the top 3 states has the highest mean elevation? It can be elevation, it can be temperature, it can be anything, right? It can be any NDVI, whatever. It doesn't really matter. Just the analogy would be like, okay, it's top 3. How about which US state has the lowest mean elevation? Louisiana? What? Any other answers? Florida? We figured it out, right? So this is where you can run computation to get the answer. And all you need, how complicated is this? One line of code. Give me the image, give me the boundary, the vector data, and then we give you the output and the statistical types. We're going to calculate the mean, basically take all the pixels within the state and then calculate the mean. And you can run the scale because the original data is 30-meter resolution. You may not need the 30-meter resolution. For this kind of large scale, you can do one, or like, for example, 1 kilometer. How long does it take? 1 second. You get the result. And on the left side here, you should be able to, for example, get the CSV. It should be downloaded to your Google Collab, and then I can open it and take a look. Now I have this mean column. Basically, this is in ArcGIS is like called zonal statistics, right? Zonal, basically by zone. So I have the DM, and you can do the sorting, but I can also do it from here. For example, I can just write gmap.csv to df. Then you'll be the out DM. Oops. So I turn it into a data frame, basically a data table in here. Then I can do the sorting. So it'll be sort values, and then I can use the column called mean. All right. So now I'm going to sort by value, right? So from the lowest to the highest. So what's this one? Colorado, Wyoming, Utah. So who are the lowest? Let's figure it out. Do you guess it right? Delaware. And MP, what's this one? The Mariana Islands, Virgin Islands, Florida, Louisiana is like number 7. Florida is number 5. So, and this is some of these can run. You see, it takes seconds. You can get the answer, precise answer. You don't have to guess it. So just run zonal statistics. If at any time you need to, for example, have an image, you have the vector data, and then you need to do some calculation. It can be sum, it can be median, it can be anything. Then you can use the zonal statistics to get the result easily. The other use case, zonal statistics by group. So for this use case, for example, I have the land cover, I have the raster data, I have the vector data. And if I want to ask you, which US state has the largest agricultural area? If you're working for USDA, you might want to know, right? Or which US state has the largest forest cover? So in this case, it's no longer just the mean and the minimum, because for each polygon inside here, you have multiple land cover types. So you need to calculate by group, right? So but just by looking at the map, right, which US state has more agriculture, or is somewhere in here, this brown color. But how about forest? How about urban? How about wetlands or anything, right? You can calculate anything by here. So same thing, one line of code. Give me the raster data set, give me the vector, I will give you the output. So this one here, the statistical type is called sum. Sum means you're going to sum all the area, all the pixels together, and then you're going to give you the result. So for every land cover type, you're going to have a column indicating what's the area. So for example, if I ask you, they're working in the government, right, Texas, I want you to let me know what's the dominant land cover type in Texas, or the top 3 land cover type in Texas. So you're going to generate data, and then you see, download it, and done. So now I should have this one on my computer. Double click. So if class 81, 71, 82, blah, blah. So each number here is basically coming from this, right? So then you can start doing the sorting. For example, okay, agriculture. So agriculture will be class 82, right? So all you need to do is come back to here. And because we already have the CSV, so I can quickly show you. You'll be gmap.csv. CSV to DF, so I'm going to turn it into a pandas data frame, and then NLCD stats. Whoops. NL. What happened? Oh, I'm running running it again. Sorry, it's taking some time. But you see, I can run this one right now is using the percentage rather than the maximum area. So, so the percentage means is the land cover area divided by the state area. So that's the relative. So even if you might have a large agricultural area, but if your state area is very big, if you divide it, the percentage might be pretty small. So these are some of the things you can certainly use to figure out the information, and the output will be just like in here. So let me go back to this example here, NLCD states. Oh, I think it's override because I use the same variable name. So right now is so I can pass in here just to show you. Let me pass in this direct variable name here. All right, so this one is the absolute area. So for all the land cover type. So now if I want to figure out, for example, agriculture, you'll be like this. Dot sort values, and then you'll be class 82. All right, so 50 state and 82 would be this one, right? This column. So here, maybe I can do the ascending equal to false. So that is descending, so I can see a little bit easier. Right, class 82, and which state has the largest agricultural area? It'll be these 3. Let me scroll to the right a little bit. Which one? Iowa, Kansas, North Dakota. So you can do the ranking, right? So it can be absolute area, it can be just the percentage relative area, depends on what kind of things you answer. So it can be so many applications. It can be land cover, it can be income or whatever, like any data set that has category code. For example, it can be hurricane, it can be whatever, just raster imagery. Then you can run this one, just one line of code, you can get the result. There's so many other applications. So there are a lot more things you can do. I don't have time to cover other examples, but you can, if you have 2 images, for example, you can also run computation with 2 images. For example, how about this? Like I can show you this example. I have the DM. I also have maybe the lane cover. And I want to know, for example, which lane cover has the highest mean elevation. Basically, which lane cover is mostly in the higher high ground, which one like low ground. So in this way, there's not really a vector data set, it's a DM and a lane cover type. And then you can use, again, one line of code, you get the result. You can do standard deviation, you can do mean, you can do all kind of statistical examples. Questions? I know I'm going really fast, but you can just click and then run the example. You can adapt. You can come back later. Certainly, I would recommend you go through the documentation to do it. So lastly, here I'm going to quickly go through the exporting data. This section will be useful. So exporting data. So if you need to get the data outside of Google's engine, then you can use Geemap. Geemap is going to help you. So let me quickly show you here. For example, you have filtered the data, you get some length images. Now you need to export the data out. So one thing you need to keep in mind is it's not so easy to get the data out. Google Engine doesn't really allow you to get large amount of data very quickly. Why? If I give you an analogy, you watch movie on Netflix, you like the high definition movie very much. You want to keep a copy on a computer, and you don't like, okay, 1 second, download the 1080p movie to my computer. It's not going to work, right? Because you're going to take time, the internet, and also they don't want you to get all the data out easily. So you can get a small amount of data. If you want a large amount of data, you need to wait because it's a free resource. If everyone's trying to take all the bandwidth, then it's hard to do the computation. And if you want to download data directly to the computer, there's a certain limit. So for example here, I can show you quickly. You can draw a bounding box, for example. Okay, I'm focusing on this area. I just want a small data set. Then you can just use this one, export image. So passing the image, output file name, the spatial resolution, and also the region. Then it should be able to get this one within a couple seconds to your computer. So it's only like a couple megabytes. If the data set you're trying to download is like several hundred megabytes, forget about it. You won't be able to directly download the computer using the official way. There's some workaround, but for here, you see now I have this imagery on the left side. It should be downloaded like, it's a very small one, so it's not a huge data set. So it's only how big? 10 megabyte is fine. If your data set is 100 megabyte, then it's going to take some time. So here, let me skip to the next one. Google Drive. So you can, for last data set, you need to export to your Google Drive. And then from a Google Drive, then to your local computer. So for example, if I click this one, and you're going to send to your Google Drive, and this looks like the instant, but it is not. So you need to go to your Google Ascending account, and then from here, go to the code editor. Up right here, there's a task. This task basically is you're sending the task to Google Ascending, and every task is put into the queue. And then when the server is ready, they will export the data to your Google Drive, and then you can download the data from the Google Drive. So basically, small data set, you can download directly to your computer. Large data set, you need to put into the queue and then download to Google Drive. And then once it's ready, you'll be ready. So for example, once it's ready, you will see this blue color, and then you can open in Drive. It will take you to your Google Drive. And this is going to show you all the data set that you downloaded it. Make sense? Also, you can download large amount of data. Oops. Using this function, download e-image. So this one, you can go over the limit. So I can download the entire image, 90 meter resolution. So see this one? This one is 79 megabyte. So under the hood is basically because Google Engine only allows you to download small image. So it's subdividing image into smaller pieces, and it's downloading them simultaneously, and then mosaic them on the computer, and then so it become a large image. So this one is not something officially supported by Google Sending. It's kind of a hack. It might be not be available in the future. So, but this is kind of workaround. So you can download large data set if you want to. For example, you want to download this original 30-meter resolution, you can do that as well. I'm going to try to maybe 60. So take a look at, okay, this one is 179. It's still pretty quick. So again, use this one at your own risk because we are walking around trying to download lots of images. Kind of like you're trying to download a movie from YouTube. YouTube doesn't really allow you, right? But you can use all the tools to download. And because it's a high definition, so you can download small piece by small piece, and then at the end, you merge them back together is a single image. So this is about downloading individual one, but you can also download a bunch of images. So for example, I'm trying to filter data. I'm going to use the USDA name image 1 meter resolution. You can filter by location, and then you can see how many images in there. Okay, so this one has 7 images. Imagine, okay, I was trying to download data covering Houston for last year, for every month. There are a lot of images, right? So this, for example, I have 7 images in here. You can use this one, export image collection. So you can download all the images all at once to my local computer, and it's going to be automated. So you can download to my current directory, 10-meter resolution, and see, so they have all of them. And oops, on the left side here, now I have all the images downloaded to my computer. So if you have a lot of images to download, this can be useful. Feature collection, export, if you want some vector data, you can also export it. So for example here, this is, for example, state of Alaska. You can just use EE to SHP or EE to CSV, EE to GeoJSON, whatever. So you can get the data out directly. So raster data, usually it takes more space. The volume usually exceeds the limit. For vector data, if it is so complicated, you might also exceed the limit. But you can just EE to something, and it's going to turn your vector data set to download it locally to a computer. So for example, I can download this one as a swap file, .shp. I can download this one as a GeoJSON, right? So on the left side, take a look. Now I have this on my computer. So you can get data out easily. Again, for large data set, go to Google Drive. For smaller one, you can get it right away to your local computer. Questions? We only have 7 minutes. So the last section, I'm going to have some fun applications to show you how to create time-lapse animations. So let me show you here. For example, I'm going to create a map, and I have a region of interest. For example, this is centered around Las Vegas. And I want to create animation because there are lots of time series images in there. How do I create animation? And this one line of code here allows you to create animation. So what we're doing is we are going to use lane-set imagery. So lane-set had data from the 1980s, 1984 up to right now. So you can create animation for every year, every quarter, every month, every day, whatever you like, as long as your data support this. So just call this function Geemap.lane-set time-lapse, and then provide the ROI. Okay, I'm going to focus on Las Vegas, and then specify the output. I'm going to start the year from 1984 to 2023. And I want this bank combination, how many frames per second, give a name, boom. See? Now I have the time-lapse animation for Las Vegas. You can have the label in here, you can have the timestamp in here, you can see the changes. But this is not limited to Las Vegas. It can be anywhere. It can be Houston, it can be whatever you like. So all you need is just the bounding box. Oh, you probably want to be too big, you will exceed the limit. So something like this city level is 45. If you're doing state level, then probably it won't be allowed to do that. If you need the original high definition, it's better to download the original image and then do post-processing locally, because this one has some limit, because it's basically the GIF animation. It's going to basically take the snapshot of the imagery and then put them all together. So it's not suitable for large area, large data set. Only for small area, it's like obvious enough. So city level, I think usually fine. State level is not going to work because you won't be able to see so many changes. It depends on your data set. This is lane set. It's usually for large area for like USD and usually 1 meter resolution. Then you want even smaller because there are lots of data in behind the scenes. So think about this one. Every year from 1984. So you are taking all the images from the history. They are probably this is 100 or 1,000 images. And you just to mosaic them, create a medium filter, remove the cloud, and then create the annual imagery, and then create for another year, another year. There are lots of steps involved. It's not like easy. If you try to create this one manually, like by going to NASA to website to download, this one I can guarantee you it takes you hours, maybe half a day. You might not even be able to get this one, do it manually. But here, less than a minute, right? And you can do that for anywhere. For example, I can change this one to another location. Only just a bounding box. And this one, for example, is Hong Kong. And just wait 20-30 seconds. I will show you another example how to do that, like for any location you like. It doesn't have to be. You don't really necessarily need to use to specify the bounding box. You can do that interactively. So let's wait a little bit. Almost there. So it's downloaded. Actually, it's on your left side. So if you go to your computer, it should be somewhere here, for example. Right? Take a look. So this is Hong Kong. You can see the Hong Kong airport construction. I think up right here somewhere is the Disneyland. I believe this one here. And this is the airport. So you can showcase change it for any way you like. So if you really want, you can try it out on the fly. I can show you here. All I need to do, create a map. Okay. Now I can create animation for anywhere I like. Okay. So if you want to see, for example, let's look at Houston. It might be too big. I'm not quite sure, but we can take a look. All I need to do, maybe draw a rectangle, something like this. And then just go here, click this button. Okay. And that's it. It's doing all the processing behind the scene. And it will generate the animation and it will overlay on top of the map. You can even like create some spectral indices, vegetation, water, whatever you like. But right now we're just doing the simplest one. If your area is too big, it might exceed the limit. But we will see how big it is. For smaller area, area like this, it's probably fine. So we can get data, for example, from 1984 up to 2024. You can change the band combination. So the nice thing about this, we are accessing the original data. We are not just looking at the Google Earth time lapse, because that one is just RGB. You cannot really customize. This one, you can do a lot of things. And you can also specify by season. For example, this is only from May to October. If you're doing like snow or some like winter related stuff, you want like winter season. So you can easily customize. And this, what else? The frames per second. This one is usually how many images you want to have within 1 second. So the larger the number, the faster of the animation. The smaller the number, the slower. Oh, you can go up to a lot more. But if you make it much larger, then it's too fast. You don't really see changes, right? 10 frames per second, like within 1 second, there are 10 years. So basically, we have 40 years of images. It's only like 4 seconds. But you can change it to 40 seconds, like 1 second, one frame per second, then you'll be slower. Anyway, this might be too much. I don't know. It's taking a little bit longer. Oh yeah, it's actually exported. It's downloaded automatically to my computer, so it's actually somewhere here. Oh, you can pick MP4. Yeah, you can export MP4. So it'll be here. Yeah, it's taking too long, I think, for this area. So if you want, there's a parameter. So you can just shift tab. You say MP4 equal to MP4 was lowercase MP4 equal to 2. It will generate the MP4 alongside the GIF. Yeah. Yeah, this one probably is the area might be too big, so it might exceed the limit. Let me maybe give it interesting. Anyway, you can try it later. I don't have time. We are kind of running out of time. So lastly, maybe show you some other applications. besides, for example, the it's probably because it's running, so it's like hanging the. Let me quickly. I'm going to show you the other two, and then we should be. And let me go back to the beginning. Import the library. Oops, no, don't need this. Sometimes if it is hanging, that means that you cannot really do anything else. You need to restart the kernel and then run again. Then it should work. So here. Okay, so I want to show you last couple time lapse. Interesting one. So for example, the modis. Okay. So you can create, for example, vegetation dynamics. So if you want to see global scale or continental scale, there's a function called ndvi time lapse, and you can specify the date and the time and year, how many frames per second, and then different areas. So look at this. How cool is this? Is like longer time span, 20 years of land cover vegetation data. And you can see the changes, right? You want me to see this one, like this is more like really the time lapse, right? Going back in history, and you can see how the vegetation changes throughout the year, and it's very real, it's very live, just like human. Your heart beating like with throughout the year. And vegetation, it can be temperature, for example. And the last one is the ghost data set. So basically, keep in mind, any data set in the Google Science data catalog, you can create an animation. Any time series, because the locked up time series is just like a bunch of images, and then you're going to take a snapshot and then create a animation for you. And how about, for example, ocean temperature changes, right? It's a lot more effective than you are reading textbook, just a static one. This one actually shows you how the temperature is shifting throughout the year at different latitude. And all you need is just a couple lines of code. You can do that by location, by small area, depending on what you want. You also have a small color bar here. Do it for you. And there's the last satellite I want to show you is called GOES. So this is a NOAA satellite, geostationary observation environment satellite. So doing especially for natural disasters, volcanic eruptions, hurricanes, because you can get the data every 5 minutes. Compared to land say it's like every 2 weeks or every week or two. Those are usually for slow changing things, but for hurricanes, if you don't capture it this time, when you come back, revisit, it's gone. So we need this kind of satellite, like a very high high tempo frequency. And look at this. Have you seen this one on the social media? The Tonga volcanic eruption, right? 2022. And look at the imagery. Every 10 seconds, you get one imagery. And you can create animation. So very simple. Figure out the time. What satellite do you want to use? If the satellite have multiple data product, this is data product I want to use. And then just one line of code. Then you can get the animation. And you can download it. It's downloaded to your computer. You can join an MP4 or something like that. So it can be pretty much anything. Anything that can be captured by the satellite. You can access it from the data catalog and can generate some simple animation. And so next time you see something this on social media, you know, oh, now I know how to do that. Like it's a couple lines of code, super easy. And you can do that using coding, but you can also use the web app. I don't have time to show you here. I actually have a interactive web app, so you don't need to do coding. You can just go to my website and then go to, for example, time lapse. And in here, on the website, you can actually create time lapse. And you can draw a rectangle, and then you can upload your ROI. And so, for example, similarly, I can create this Hong Kong airport. And pretty much, oh, probably something is wrong. I need to fix it. But that's the idea. You can give it to volcanic hurricanes or something like that, right? This is something you can do easily by getting data from Google Sensing. And the last example is wildfire. So you can not only, because right now we're just not doing any analysis, we're just getting the imagery and then just render it as an animation. But you can actually run analytics. You can extract, for example, the area, the impact area, and then you can render it on the map. And you can basically combine the original satellite imagery and also your analytics on top of the data. So again, just try it out. You can just change the area, change the bounding box, and change different region. So next time, if there's any major natural disasters, you can just quickly go get the images, create animation, because all the data are being updated like in real time. So see this, like this is the wildfire, and you see you can actually keep check the boundary of the wildfire extent, and you can overlay on top of that, so you know exactly how the wildfire is actually spreading. And there's different functions for that. Most of the things is just which the area, what time, what do you want to show, and there's a couple lines of code, and you can get the result. The last section, I don't have time to cover. This one is a lot more advanced. Basically allows you to create figures or graph, running analytics. For example, can be temperature, can be some lane cover classification. It can be, there are a lot of cool stuff in here, but this is for your own study. And at the end here, I also put some exercise. So if you want to try it out, you can run some of these exercise. For example, how to do some simple clipping, DM, or how to create, for example, some cloud-free mosaic for your area of interest, using different data set for different county, how to visualize vector data, and how to create some simple maps to compare different one. And the last one is how to create an animation for yourself for any location that you like. Okay, so we already over time 7 minutes. So any questions? $11:45? Oh, that's great. I saw it's like 11:30. So what do you think? Do you learn something new? Do you find some useful applications? They might be useful for you. It's a lot of information, but spend some time, go through that, and if you want to learn more, you're welcome to go back to the Geemap website here. And again, I'll post the videos later today, but there are a lot of examples in here, also novel examples. I've developed over 150 examples. So the workshop actually is a subset of these examples. I put all the things together, but you're welcome to go through that. There are a lot more information. So what we covered today is probably maybe 5% of what Geemap can do. I also published a book here. If on the left side, you can go click this one. You can, it's all open access. So this one is even a lot more content. So you can actually go through the book, and you have all the text describing how to use it, all the sample codes. You can open this one directly from Google Collab, so you can run through the code block, and there are a lot more content in here. So what we cover, for example, time lapse, I only show you a couple examples, but you can do that for any satellite. You can also build interactive web apps. So there are a lot more content in here if you want to learn more. And if this is not enough, you want to learn more, you read the Earth Engine documentation, or from time to time I also like post videos, so you can go to my YouTube channel. I think I have 700 videos there. Take you maybe I don't know the total length, probably a week or two non-stop if you're watching that. So I do have a lot of videos. For example, Google Engine. I also teach programming, 3D. There are tons of videos available on my YouTube. So if you want to learn more, check out my YouTube channel. And lastly, if you have questions you want to ask, like in the future, you can, let me show you where to ask questions. So you go to Geemap and then go to GitHub up right here. There's a discussion board here, so you can ask questions. You see most of the questions that usually get answers within 24 hours. Free customer service. Ask questions, so you can search questions that people have asked. If you find any bug, you can report the bugs in here. If you are capable, you can contribute source code. It's open source, so everything, all the source code is actually available from here. So you can look at the source code, see how it's being done. And so for every functions, there's documentation and there's things in here. For example, this one contains thousands of lines of code, 14,000, right? So all the functions have been well documented. And also, for example, for time lapse, there's the dedicated module for creating time lapse, right? A couple thousand lines of code that right now, from the workshop that I cover, like only one line of code can create lane set time lapse for any location. That function is like many lines of code behind the scene because it does all the computation. So I can show you here, for example, lane set. See if we can find it for you. For example, lane set time series. For example, lane set time lapse. Take one line of code that we use to create time lapse for any location. I don't know how many lines of code. Yeah, and this function actually calls other functions, so actually it's even longer than that. So if you really want to like dive deep into how this is being done, you're welcome to look into the source code. And again, it's open source; anyone can contribute. So if you find it useful, feel free to use it. You don't need to pay me. You don't need to contact me. It's all free online. So if you have questions, you can reach out to me on social media, on GitHub, or email. Okay, that's all I want to share with you, and happy to answer any questions. The slides will be here. If we go to the, let me see here. Yes, it's on Amazon. But usually I don't recommend people buy the book because it's all the source code is on there. Here. So yeah, so the screen. Yeah, so this you have access to all the source code. And if you want to buy it, you can buy it from the publisher. There's a PDF version. There's also a hard copy, and I don't decide the price. So to me, it's a little bit costly. So I never ask my student to buy the book. Just read it online, and if you want, you can buy it from the. You can buy a PDF copy and also a hard copy from Amazon somewhere. Yeah. Yeah. Mm-hmm. JavaScript. So Google Engine support JavaScript and Python. I only do Python, but the syntax, the internal computation is very much similar to JavaScript because you're using the same API. So behind the scene is actually JavaScript and Python. They're the same. They are being converted to REST API and then sent to the server. So it doesn't really matter what language do you use. The advantage of using Python is because Geemap simplify a lot of stuff. So you can like change the symbology, change all kind of things, create time lapse. That kind of thing, it can take you hundreds of lines to write in JavaScript. So Geemap simplify a lot of things, and it's easier to basically build on top of what people have done. For JavaScript, you need to write from scratch, and then you need to import the script. It's not as convenient as Python. So that's why a lot of people nowadays use Python. But you can just adopt the example. So there are tons of examples. For example, analyzing geospatial data, there are a lot of source code in here. So different use cases, exporting data, or you can even create some high quality maps. Of course, these are kind of a lot more complicated, but certainly there are a lot of things you can do. Even just using geospatial data, there are a lot of examples in more detail. So the book, right now, this only shows you the source code, but the PDF copy and the hard copy have all the text and all the images, just like chapter 1 in here, describe and all the explanation. So if you want to support to buy the hard copy, thank you. Please go ahead. If you just want to read and then practice, if you are a good programmer, you don't need the book. You can just run the code, explore, and then change things. But if you really want to learn in depth, then you're welcome to buy the book. And so, for example, here, if you want any, I can just open this one in Collab, and you will take you to Collab, and then you can just like what we did today, you can run through the code block. You can learn everything for free. All you need is just some time and some patience. That's it. Yes? Say that again. Yes, I will post the video. Hopefully the recording is successful. Yeah, I will post the video later today. Yes? Uh-huh. What do you mean? So you want the map to be on the website? Yeah. So all the maps, yeah, you can certainly do that. But problem is that all the Google Sensing data layer are temporary. So it's only valid for 24 hours. Even if you can embed, for example, all the data layer that we are showing there, except those, for example, the animation, those things we already export to a local computer, those are permanent. But for any other Earth Engine data layers, they are temporary. So after 24 hours, the link is expired. So you cannot do that. But for a lot of simple maps, yes, you can do that. So for example, here, I can go to my div map. This is the one I'm going to cover this afternoon. This one, you can embed a map on the website. So for example, I can use base map. No, this one. Let me. For this. For example, this will be interactive. So the map on the website will be interactive. So you can actually interact with the map. For example, region. Hopefully it works, right? These things. So you can certainly do that. And the one I'm going to cover this afternoon will be Map Libre. So for doing 3D mapping, I'll look at the example in here. I also have the demo. So if you want to, for example, learn how to create 3D map, for example, 3D buildings, you can turn it into HTML, and then other people, you can send the link to other people. So it'll be like this. Right? You can do it at global scale. So it's very powerful. You can do, for example, Google Sensing. I can visualize data in 3D, and I can overlay Google Sensing data on top of the 3D. It is. So there are lot of things you can do. It depends on what you want, what kind of use cases. They are locked. So if you use Google Sensing, then you can use Geemap. If you don't use Google Sensing, then you can use Leafmap. Again, this has a lot of example here. This one over like 100 notebook examples. So for this afternoon, I will cover some of like the highlights of using this. Again, the notebook is here. The same content, but it's for like 3D mapping. Any other questions? If not, thank you for attending, and let me know if you have any questions. You can feel free to reach out to me, and I'll post a video later today. I never sleep.